It's not as hot as it has been. Been really like absolutely baking. As always, starting around about the same time. We've kicked off a little bit early because actually we've got so many things happening today. We don't really have a lot of slack, and I know people like me to say hi at the beginnings and stuff like that, and call out the people that are here. Let me have a look what we've got. I need to minimize that chat. Good morning. Hi, Terry. Good morning, everyone. Terry is always here. He's one of our many people. I'm sure Patrick will turn up sooner or later if he's not already in the chat. And what else have we got? Oh, I need to, sorry, let me just make something go quiet. Otherwise, it will go bing every 2 seconds when people message me. Pete Rios, I'm now receiving people apologizing for not coming to the stream, which is absolutely fantastic. You know, it's optional. You don't have to turn up every day, but I'm really glad that you do. We have a lot of people that turn up regularly, and Pete is one of them. He's off to the doctor's appointment, but I've said, all right, good luck. I hope it's nothing serious. I hope it's just like a routine checkup to check you're still a human, you know, that kind of thing. And what else have we got? And China Safarov, I hope I'm saying that properly. I'm just going to move my microphone a little bit nearer. It says hello. Hello, China. We are going to start on the hour today, which is in about 8 minutes' time. Let me see. I'm going to put my schedule, or however you want to pronounce it. I always pronounce things in multiple ways, and people always say, oh, that's not how you say it. But you know what? I have an accent, and that's the one I use. So in 8 minutes roughly, we have got quite a good session, a 90-minute session from Michalis Kambarelis. I just call him Michalis because I always mangle his last name, and he is the chief of the Castle Game Engine, and he's going to be doing a session about coding games, actually writing games using Delphi. The Castle Game Engine is very interesting stuff, and this is what this session is all about. I've had a brief look at the video, and he goes into depth about what it is, how it works, and all the rest of it. After that, at midday, which is in 2 hours' time from now, we are going to have Juan Castillo back. He's going to do a session about advanced usage of logging. He has a logging tool that does some quite unique types of logging. It does multi-threaded logging, and just, you know, it logs in a certain way. He did a basic session before, and he's now going to do a follow-up session to talk about some advanced usage of it. When you start to get things like trying to log web app, and as Dion said yesterday, they have an app where they have 1,000 people or more. I forget how many he said it was simultaneous, but it's a lot. Might even have been 10,000, but anyway, it was more than just a couple. Once you get to the level where you've got that many simultaneous users, even just a simple log to say so-and-so logged on can get to the point where you get a thing called a thread deadlock, where you're trying to write to a log. So Juan Castillo's Huac log, or Jack log, he pronounces it better than me. He's Guatemalan, and he's got the accent to go with it. His Jack log, his logging tool anyway, can cope with that kind of pressure where it doesn't, jam a multiple threads where multiple users are trying to write to the same file at the same time. It actually copes with that and handles all that kind of logging. He's going to show how that can work. If you find that your app, just when you're trying to write a log out and it just suddenly freezes, it could be that's one of the bottlenecks, because actually writing things like the event log and stuff like that, it is optimized in Windows, but it's still, there's a penalty. You're still, writing out an API, and there's a call, etc., etc. So things like Juan's logging tool help with that. And then an hour after that, so in 3 hours' time, from now, there will be a live session from Miguel Angel Moreno, who you saw yesterday doing a C++ session. Today, he's going to do a Delphi session, and it's called Resource Allocation is Initialization for Delphi, RAII. I have to say, I don't know what that session is about. I know what it's about, but it's good. You know, I haven't had a chance to preview it because he can do it live. He did a very good live session yesterday for C++, where he mentioned RAII, but this afternoon he's going to talk about that. We have got some really good sessions coming up this week as well. Tomorrow, the first session will be from my colleague Antonio Zapata. He also works at Embarcadero. He's a very, very talented developer. And he's going to show a simpler approach to dynamic web applications. He's going to be using HTMX. So if you are a web developer and you're interested in how to do some dynamic stuff, then Antonio's session shows how to do that, and also how to do the back end with Delphi and other things like that. So if you're at all interested in Delphi with HTML, this is the session for you tomorrow. We'll follow in that with a great session from Jaroslav Brovin, a smart backpack controlled by a mobile application with FGX Native. You can't get much more cutting edge than that. Smart backpack with a mobile phone controlling it. Fantastic. Really interesting session. I've seen Jaroslav present sessions before. Very smart guy, knows exactly what he's doing. Then we're going to have a little bit of a break tomorrow, and then we're going to follow that with Easy DB Migrator from Ali, and follow that up with some sessions about Yellowfin. Yellowfin is an Idea company, and if you are a corporate or an enterprise company, you've got big reporting needs, and Yellowfin is the tool for you. And the person that's going to be demonstrating it is Edgar Kutzner. He's a very smart guy. He works with Yellowfin. He does effectively what I do. He knows how the product works and then demonstrates the benefits of it in the nice, easiest way you can do. So he's going to talk about how to maximize customer value with embedded analytics in Yellowfin and do an overview. There is a Delphi sample as well, a Delphi sample that shows you how to embed Yellowfin in Delphi apps, which many people find extremely useful. And then on Friday, we're going to start off with a really good session about Ultra Edit from Bradley Hawkins, followed by functional programming by Dr. Kevin Bond, who is an educator and a smart guy as well. And functional programming, if you don't know what it is, because it's one of those techniques that it has a benefit over object-oriented, pure object-oriented programming and straightforward procedural programming. Functional programming, learn all about it, followed up by something else advanced, which is coroutines. What are they? And Paul McGee is going to explain all of that. And then we are going to look at the Open API wizard from Ali Demban. Again, that's his last session. He's really been pretty prolific, Ali. I appreciate all the effort. And follow it up on Friday. The last session will be from Marco G from GDK. So Marco is the G in GDK. If you knew anything about the Delphi Summit, which was absolutely amazing, one of the best in-person events for developers in the Delphi Rad Studio world. Marco's company ran it. He's going to do a session all about Delphi tips and tricks and how to get the most out of the idea and out of Delphi. Definitely worth watching. I'm just getting a little message here. Yes, Michalis. Michalis is in the back end of our studio and just asking if he's in the right place. Yes, you are. That is correct. What you've typed there. And it's all good. Right, let's see where we're at. I don't want to start it exactly at 10 because people get confused. Let's see who we've got. We've already said hello to Terry and China, excuse me. Patrick is here. Salut, Patrick. Eventually by the time I finish, everybody is going to keep saying salut to Patrick all the time. Follow him on Twitch if you don't already. He's an absolutely amazing streamer. He said he's going to take a break at the weekend, but I think he said next week he's back to streaming on Twitch. And Patrick is a games developer as well. He writes his own games. But he said not only games but 3D games. Yes, absolutely. And Michaelis is going to explain that any second now. Um, Nolan says hello from Taipei again. Hello, Nolan. Thanks for joining us. You've been here every single day for these webinars. I really appreciate it. Peter, hello, Peter. I'm going to guess that you're possibly Polish. If you are, then dzień dobry. If you're not Polish, then I apologize. My stepfather is Polish, so I know a little bit of Polish. Who else we got? Morning, you mean? Ron from Montesano in Washington. Beautiful area, actually. And who else we got? Adele from Agadir. Hello, Adele. Thanks for joining us again. And of course, one of the many, many, many Brazilian developers. I will be there on September the 5th at the Embarcadero conference in Brazil on September the 5th. And if anybody's going and you're Brazilian, hi, bom dia. I will see you on the 5th. And hello, Jean. I'm going to assume that you're in Montreal. So bonjour and hello, depending on what language you use. And who else have we got? Yes, thanks. Dzień dobry. Yeah, there you go. I guessed correctly. Yeah, my stepfather's Polish. He was my stepfather when I was the age of 11. So I've kind of grew up around Polish culture quite a lot. He's still around, but he's very, very old now. Bless him. But yeah, dzień dobry I was taught how to say that properly. It's one of those words that you have to do. And if I say stolat, you know exactly what I mean as well. If I sing stolat, yeah, I know how to sing that as well. Okay, all right. Well, enough talking from me. We have a session now, which is from Michaelis. I'm just going to see if, oh, yes, Martha has been, producer Martha, as always, works extremely hard, despite traveling around the world. She's extremely busy, very active, and always manages to look after me and make me look good. But she's done these titles for me, so it makes it easier. So our session now is about 90 minutes recorded. And then Michaelis is going to join us afterwards for a live Q&A. And this session is coding games using the Castle game engine and Delphi. I'll see you soon for the live Q&A. Actually, I'm going to play it this way, because that video did not play. Okay, now we're going to go live. Sorry about that, everybody. A little bit of a gremlin.
Okay. Hello everyone. Welcome to the lecture about coding games using Castle game engine and Delphi. Short agenda, what we are going to talk about. First, I'm going to talk a little bit about myself, just a little bit. Then I'm going to talk about the Castle game engine, what it is, how we're doing what we're doing, and what it can do for you. Why I think it's kind of worth your time to try it out and do some cool stuff with it. And then I'm going to shortly introduce how you can install the engine, download and install the engine inside your Delphi, and then how you can use the engine editor, which is our visual tool to design your games. Then we will jump to the main course. As the title of this talk kind of foretold you, we're going to do a lot of coding. We're going to code a fun game using Delphi, Pascal. This is going to be like the main part of our talk actually. And then I'm going to also shortly mention, well, okay, I already mentioned it, that we also support C++ Builder. And then I'm going to talk about some plans. So a few words about me. I'm the project lead of Castle Game Engine. I'm the developer of Castle Game Engine. I'm doing this project. I'm doing it for all my life by now. I'm doing it because I believe that we should have an open source game engine that allows you to design the 3D and 2D games that you dream about. And that you also should have ability to use a modern and type-safe language to code your games, like Pascal. So that's why we're doing what we're doing. Short version. I'm also the developer, currently the maintainer of PassDoc, the documentation generator for Pascal. I also wrote something called Modern Object Pascal Introduction for Programmers. I work a lot with people that code in various languages and use various other game engines too. And so I kind of wanted to address, like, how would you learn, how would you teach Pascal to somebody who already knows some programming languages like Java, C Sharp, C++, whatever, and like to introduce to them Pascal in a way that how to showcase them the modern feature of our language in a way that is kind of friendly to them and also like fast for them to learn. I'm also involved in designing specification of some 3D standards. I'm a firm believer that the open 3D standards are our future, that they allow us to actually cooperate better. This is also a very important feature of our Castle game engine, but it's also important, well, for a lot of other software. So I'm a member of X3D, of the Web 3D consortium that designs the X3D standard, and I'm the liaison between the Web 3D consortium and the Kronos. Long story short, I'm also looking at how the GLTF standard is developed. Those two names, the X3D and the GLTF, they are 3D formats that are supported in an incredibly good way in Castle Game Engine, and we want to like put a lot of emphasis on them because again, I think that supporting those standards is important because it also allows you to use Castle Game Engine easily because you can export to those formats from a lot of authoring tools, for example, from Blender. Yeah? So I already started talking about Castle Game Engine, even though on the last slide I was supposed to talk about myself. So the engine website, go ahead and visit it. The point of the engine, well, you have to do two things with your games. You want to design them visually, and you want to write code that handles your game logic. Both those things are super important to actually write useful, successful, fun project. Okay, so two things, yeah. So we have the editor. Editor allows you, Custom Game Engine Editor, as our tool that allows you to manage your projects and to design your worlds. You can create a three-dimensional or two-dimensional worlds just by dragging stuff around, picking them. You can observe immediately how those things look like. You can think of it like, a bit of a form designer in Delphi, but here for games and also for 3D. So kind of a different thing, but with a similar purpose, yeah? So you can quickly jump in and design what you want to design. And then, so that's one thing, yeah? Visual design. The second thing, okay, you also want to write code because a non-trivial game will require some code, and you like to write code, right? Because that's why you're here. So you want to write code to handle your game logic. And for this, we have this powerful API using modern Pascal, using classes, generics. It allows you to do everything. And the important thing is also the connection between the editor and this API. The thing is that everything that you design in the editor, those are just components. Those are just components, T component in Pascal. So everything you see in the editor, it is just a class in Pascal. Every property you see in the object inspector in the editor, well, that's a property in a Pascal class. So those two things, the editor and the coding, they match. They match. It's incredibly important that you're actually doing the same thing and you have a choice whether to do it visually or whether to do it from code using Pascal. We support Delphi, C++ Builder, Free Pascal Compiler. We are cross-platform. It's a heavy emphasis on the engine. We support desktop, Windows, Linux, FreeBSD, macOS. We support mobile, Android, iOS. We support also Nintendo Switch. We have actually plans for much more platforms. The important caveat here for the Delphi users is that right now we support only Windows and Linux platforms with Delphi. We do plan to improve it. We have planned probably the next platform for Delphi will be Android. Okay. Right now, you can use the engine with Windows and Linux with Delphi. Okay, we are open source. The engine is completely free. Everything we do is just available for you for free, although you are more than welcome to actually donate to what we're doing and we'll support it. Yeah? But it is available for you for free. The engine is available on a permissive LGPL license with static leaking exception. Long story short, you can use the engine in proprietary commercial or not in a proprietary closed source projects. You can. That's okay. And the last point is that you can design the both three-dimensional and two-dimensional games using the engine. To actually look at the broader picture, you can design any game type using Castle Game Engine as a general purpose game engine. You want to design like space shooter in 2D? Go ahead. You want to design a first person shooter in 3D? Yeah, go ahead. You want to do a third person shooter where you see the avatar? Yeah, go ahead. I mean, so you can design all the visual novels, adventure games. Okay. I could go on, but you get my point, yeah? I mean, this is a general game engine. It allows you to render, animate, process stuff, and audio, physics, and everything. And you can use it to design, well, any kind of game you would like to make. Okay, so let's jump to the leave part of this presentation, in which I want to show you how to actually download and install Castle Game Engine on your system, and what are like the first clicks, the first actions I advise you to take when you get Castle Game Engine installed on your system to make sure that it well works and it's well integrated with your Delphi. So let's go to the Castle Engine website, castle-engine.io, and click on the download link. Now you want to choose your operating system. You're using Delphi. So we're on Windows, grab the Windows version and install it, of course. And when you have installed it, you will have Castle Game Engine entry in your Windows menu. Well, run it, of course. And that's our Castle Game Engine editor. Now, you should do two things here. You should configure in preferences the editor to make sure that it's integrated with Delphi. So go to the preferences and click first of all on the code editor. You probably want to choose Delphi as your code editor. You may choose other things, for example, Visual Studio Code. We have a great Visual Studio Code extension to support using Castle Game Engine in Pascal in Visual Studio Code. But long story short, well, you probably want to choose Delphi if you're used to using Delphi to code in Pascal, and then you also want to choose Delphi as a compiler for your Pascal code, okay? So click OK, and there you go, the preferences are okay. Once you're here, I would actually just advise you to, well, also try out the Castle Game Engine editor to make sure that everything works. And well, to do it, just create a new project. Create a new project, pick some interesting initial template. I would usually go with the 3D first-person shooter game template, add a name for it, and there you go. That's how the project in Castle Game Engine initially looks like. Now you want to actually double click on one of those views and observe how it looks. So that's Castle Game Engine editor. You can move your camera around. You can move your stuff inside here. Okay, Castle Game Engine editor works. We will go more into detail about this, more in detail how to use this in next talk sections. Okay, so once you have it ready, I'll go also to the Delphi. In Delphi, you want to install Castle Game Engine packages to make sure that when you build Castle Game Engine applications from Delphi, then Delphi knows where the Castle Game Engine units are, and it can use them automatically to build your projects. So, to integrate Castle Game Engine with Delphi, well, open the group called All Packages in Castle Game Engine. To do this, navigate to the directory where you have installed Castle Game Engine, pick the subdirectory Packages, subdirectory Delphi, and choose the All Packages project group. Okay. And there you have it. It contains a few packages. What I would advise you, what is like the safest, I guess, thing to do, is to right-click on all the packages except Castle Engine window. Right-click on all of them and click Install. So I'm going to choose first the base Castle Engine package. Right-click and then Install. And then I'm going to choose the second package, which is the VCL component. Again, right-click, install. All right. And as you can see, it has said that it's installing a new component called T-Castle Control in the VCL version at this point. Now, another package, the FireMonkey component. Again, right-click and install. All right, it's installing the T-Castle Control for FireMonkey. Now, go to the Castle Engine Design. And again, right-click and install. Once you have done it, once you have installed the Castle Engine Design package, you will see a new mini item in your Delphi IDE. Go to the Tools, Castle Game Engine, and there it is, a bunch of useful Castle Game Engine configuration options. You really, for start, just want to use two. First of all, set engine path. This is the part where you have installed Castle Game Engine. So I'm just choosing the Castle Game Engine and saying yes. And the second menu item I want to use is I want to say configure Delphi to use engine. Okay? And well, I already had my Delphi configured to use the engine correctly, but well, you will see something else here. You will see that a number of paths, a number of engine paths, each for the specific platform also, has been added to the Delphi configuration. Once you have done this, you should restart your Delphi, because what we're doing is we're changing the Delphi configuration using the registry, because there's no API right now to change it more directly. So you have to restart your Delphi and then everything is good. And if you will build Castle Game Engine applications from Delphi, well, it will just work. It will automatically find Castle Game Engine units. And well, that's kind of it about Castle Game Engine installation. But I guess now the thing that you really want to do is, okay, you have just created a project like 1 minute ago. How do you actually build that project with Delphi? Well, let's go ahead and do it, right? So I'm going to use Custom Game Engine Editor. I'm going to open the project, the amazing project that we have just created, 1 minute ago. So I'm going to go and open the project in Delphi. I can do it by clicking Code, Open Project in Code Editor. That's why we have configured in preferences that the Castle Engine Editor should invoke Delphi. Alternatively, I can ignore it and I can just open the project in Delphi. I mean, it's just a Delphi project. There's nothing really magic about it. So I'm going to open the project in my users subdirectory in Documents, Castle Game Engine project. It's called test-3d2 because that's why I named it. That's how I named it. And it's just a Delphi project. So I just open it. And here's a bunch of useful information. There's also a useful Pascal code that we will explore in a second, what I can actually do with this project. But you want to do the first obvious thing is you want to run it. You want to run it with debugging. So go ahead and do it. Yeah? Okay, and that's how the project looks like. So this is the main menu of our application. We will see shortly how to do something like that on our own. And as the play view of our application. And also we will see shortly how to do something like that. Here you can walk around. It's again in the first person perspective. It's using the T-Castle walk navigation. Let's jump to what I would call the main section of this talk, probably the longest, hopefully the most fun also. So we're going to make a game. We're going to make a game where there's a pirate and the pirate is shooting balls from her hand. And those balls will try to hit the skeletons. So the skeletons are our enemies in this game. The skeletons are generally our enemies in most games. Never mind. The pirate shooting balls into skeletons. Okay, that's our game. As you can see on the slide, well, I kind of played a little bit with the assets, the three-dimensional assets that I have downloaded from the Quaternius amazing open source assets. I'm going to link it to them. And then, so I played with the assets, but I haven't actually made this game that I'm thinking about. And well, we will see what happens during our talk. We will see what we will actually make. Whatever I'm going to make, I'm going to put on the link in the public repository in the Castle Game Engine organization on GitHub. So on this slide, you have a link. This link is working. When you are watching this video, this link will work. And you will be able to download the project that we are going to do right now on your computer, and you will be able to play with this project. But also you can just ignore this link, just go ahead and do your own game, following or not following what I'm talking about, and have fun. Okay, so let's jump into it. So a short plan, a short roadmap, what we are going to do. So the first thing is we're going to explore what are the views in Castle Game Engine, and we're going to handle clicking on a button. Not very impressive, but it's a start. Then we're going to handle the input because we want to move the player on our seat. In our viewport. And we are also going to learn actually how to place the player in our viewport. So, well, you will be able to design user interface and three-dimensional stuff in Castle Game Engine Editor. Then we're going to make missiles, canyons, balls that are shot by the player. And for this, we're going to do something like reusable designs. If you come from Unity background, Those are called prefabs in Unity, while they are called reusable designs in Castle Game Engine Editor. So we're going to use them to spawn missiles, balls that are being shot by the player. And yeah, we're going to spawn them and we're going to see what happens when they hit the skeletons. The skeletons will walk around the level. I mean, not around the level, they will just walk left and right, left and right. Very boring enemy logic, but well, it's something. And then when the missile will hit a skeleton, we want the skeleton to die. And that's it. Okay, so let's start by creating a new project, and I'm going to call it Pirates. All right? Create a new project. As you can see, this time I have chosen the empty template for my project. Well, because I want to show you how everything looks like when you kind of just start from scratch. And this is again Castle Game Engine Editor. Okay, you saw it. Now, what is this thing now at the center of the screen? Yeah, I already said that this shows the views in your game. Well, what does it mean? Well, a view is something that basically takes over your window and displays something in your window. For example, a main menu is a view. Playing the game is also a view. Showing the credits is also a view. In a way, a view is a bit like a form in Delphi and Lazarus applications, except all the views, well, they actually are contained within the same window. I mean, like the frame doesn't change. It's just the contents of the window change to either show you this main menu, the credits, the pause menu, the game, and so on and so on. So yeah, if you think about Delphi forms, it's a good way to think because you basically split the user interface of your Delphi application using VCL or FireMonkey. You probably split your user interface into forms. It's only natural. And that's the same thing that you will do in Castle Game Engine. You will split your user interface. It's like the first version of splitting your logic is to split it into a number of views. So at the beginning, we have one view called the main because that's how the empty template looks like. And this empty view, well, I mean, it doesn't contain anything much useful. It just contains a label that will display the frames per second, which kind of shows you the speed of your game at runtime. Now, each view is connected with a Pascal unit. Again, exactly like Delphi forms, yeah? So we have this view called game view main, and with this we have a corresponding Pascal unit called game view main. Let's go ahead and take a look at this unit in Delphi, of course. So let's open it. So I'm going to open my user, documents, Castle Game Engine projects, and the Pirates game and the project in Delphi. And this is the Pascal code of our view, game view main. And as you can see, like this view in editor contains a component called label FPS. And there's a corresponding declaration for this component label FPS in our view in the published section. And then there's the code of the view. Well, nothing fancy for starters. It's really what all it's doing really for starters is just actually saying that this label should display the frames per second. It should be updated all the time to show the current frames per second value for our game. Frames per second is useful to see in games. Well, to know how fast they are. I mean, you will see how whether the game is slow or not, but it's always better to also have a number. You know, it's like objective way of measuring your game speed. Okay, so that's the frames per second thing. So, well, we want to design here something more interesting. So let's go ahead and add the user interface component. And okay, so let's say that the first thing that we want to design is actually a view that contains kind of a main menu of our game. And so we want to have some impressive graphic assets for our game. And for this, I'm going to use Quaternius pirate assets. Assets depicting the pirates and some environment, some fun environment in which the pirates live. So that's a pirate kit from Quaternius. Amazing models in a lot of formats, public domain. You can use them in your own games as you like. And then, yeah, I kind of advise you to support this guy. He's amazing. He's doing great graphic stuff. And we're going to use his stuff right now in our example game. So I have already downloaded it. It's lying on my disk in the Quaternius subdirectory, Pirates subdirectory. Okay, so how do I move those three-dimensional models contained there into our project? Well, the thing is that Castle Game Engine project is just a directory on your disk. So you can right click on the data subdirectory in your project. You can open the containing folder, and there you go. Those are the files of our project. If I want to add here some files, well, I just copy them. I just copy the files. That's all I'm going to do. I have to do to add the files to my project. And there we go. Now in the Castle Game Engine editor, in the bottom, you can see the subdirectory Pirates, and this contains all the assets that, well, we're interested in. Let me move the camera a bit. Okay, so now I'm going to explore the subdirectory. So it contains the subdirectory GLTF, which contains the model in a format called GLTF, which, as I told already before, it's a very important format for us, and I'm going to use it to design, well, kind of everything in our game. So it contains the GLTF models like this. And as you can see, when I click on those things, like the preview in the bottom right corner fires up. So I can see those models even before I put them on the scene. And more thing is the other thing that actually this project contains is some fancy graphics, and I actually want to use this graphic to show it on the main menu, like as a background of my game. Okay, so this is like the main menu. Okay, not the final game yet. I want to like show here some fancy graphic. So I'm just taking this preview PNG and I'm just dropping it on our view. I can move it around. I can also just say that I want to stretch this image into whatever size I want to. I can position it at any place on my screen. Okay, so I can do something like this. So that's just a regular image in our user interface. Now I probably would like actually this image to fill the screen. For this, I can say that the image, it's already should stretch. It should also always follow the aspect ratio of the original image, like this. Okay, so great, we're getting closer. So we have something like this. And I want the image to actually fill the screen. So for this, I'm going to set the width fraction and the height fraction to 1. And I also going to recenter this image. Now, what has happened now? Now, whatever I will do with this image, whatever I will do with my screen size. So if I will look at it like this, if I will have like very landscape aspect ratio, or if I will have a very portrait aspect ratio, so you can see like the image fills my window, fills my screen as best as it can. Okay, so that's the image in the background of my main menu. I want to kind of cover it to make it kind of a bit fade into the background. So I want to actually put a rectangle control over it that is a bit transparent. So I'm going to set alpha to something like more or less 0.3 in this case. And let's also make it a bit darkish, okay? So this rectangle is kind of, it's a blackness with a bit of a transparency, okay? So if the alpha goes to 0, it does nothing. If the alpha goes to 1, it's completely black. Somewhere in between is the effect I want, okay? So the image is kind of dimmed in the background. Now on top of those things, I want to display buttons. Well, I actually really want to display one button for the sake of this demo, one big button that says play the game. I also want to display the game title, okay, because I guess this makes sense. So let's add the user interface, and well, I can just actually add a button here, okay? So user interface button, and I can say that the caption of the button is play the game, okay? I can make the font of it a bit larger, I can increase the paddings here, to, well, kind of look better, yeah, because it's just one big button. What can I do more? Well, I can also actually place it in a group. So, for example, if I would really like to make it a menu, I probably want to have a few things horizontally or in a horizontal or vertical layout. So let's actually do this layout because it's very easy. I can just start creating a vertical group, and now I can drag the thing that I've done into a vertical group. And now, if I would, for example, I can like move the entire group. For example, I can just move the entire group to the center of the screen. If I would like to have more buttons, I can just place duplicate on this button. And there we go. There we go. Here we have a number of buttons. They are all in this big vertical group on the screen. And I don't really want to have more buttons at this point. Okay, just play is good enough for me. Let's actually add one more user interface, a label that is going to be the first user interface element here. And I want this label to be displayed in yellow. I don't know, because I like yellow. I think that's good enough reason for now. So I want this label to say the name of the game. Pirates. Pirates. That's good enough. Okay, and I want to align it also nicely. And maybe let's add some space, okay, to make it look good. It's reasonable. Yeah, it's reasonable for this done. So this is our first view where we have designed a menu, and now we want to allow the player to actually, when the player presses play, we want to actually the game to happen. Okay. Now to make the game, I'm going to actually create a second view called play. And there I'm going to put, like in this platformer demo where you saw, in the play view, I'm going to put my main three-dimensional stuff, my main character, my enemies. I'm going to put them there in this view. And so we want a second view. So let's first close the design, okay? Because this is good. This is golden, yeah? And so let's create another view, new view, and let's call it play. And as you can see, I mean, I'm just feeding the base name of this view. I'm going to call it play. Everything else is kind of automatic, yeah? Because all the defaults are good. I just type play. I press OK. Now it's asking me where I want to actually edit this new play view that I have created. Of course, I want to edit it. And at the beginning, it's just empty. So the first thing I want to do is I want to create a new user interface here. It's called a viewport. Now, this viewport is like your window into your game world. A viewport has a camera, and whether it's three-dimensional or two-dimensional, the point of the viewport is that you can move this camera, and this way you can kind of influence what the player sees. And also you can at the design tab on the editor, where you can design what the user will see, what is present in this world. So this is our viewport, this is the cam. Yeah, so this preview, the camera one here in the corner, this is what the user will actually see. Okay, in the big view, in this thing, this is my view when I design the game. The idea here is that I like look at everything from this angle, yeah. But what the user will see, is visible in this camera preview. I can make it bigger, larger, I can pin it so it never disappears from my view. So that's a camera view. Okay. Now when I'm moving the camera, what player sees is changing, of course. Well, that's our initial view of the game. I mean, let's call it good enough for a second. It's not good enough. We're trying to go back and change it to make a real game, yeah? But let's call it good enough for a second, because now we want to actually take a step back and we want to make sure that the user can actually run this game. When I go to the game will initially display this main view with the big button that we have designed. Now we want to add some code to make it so that when the user presses the play button, then the view actually changes from the main to the play view. So how to do it? Well, first of all, let's close this play view. Let's open again the main view, because we want to do one additional thing. We want to assign a reasonable name for our component. And I'm going to just call it button play, okay? So that's the name of the component that I want to use to refer to this component from Pascal code. So let's save it, design, save many item, and let's switch back to Delphi. So again, we have the game view main Pascal code, and you should notice that in the same directory, we now have a new unit called game view play. And this is, it's not doing anything. It's kind of just like a placeholder for us to place the main logic of our game there. Let's go to the game view main. We want to handle this button play there. So first of all, I want to define the button play in the published section of our view. It's kind of similar to what Delphi is doing automatically for you when you design components on a form, except we don't add those components automatically, because well, some games have like hundreds or even thousands of components. You don't really want to access them all from your Pascal code. So right now you declare the field explicitly for the components that you want to access from Pascal code. All right, enough talking. So I have now the button play, and I can do something useful with button play from my code. Well, what can I do? Well, I go to the start method, which is run when when the view is actually shown. And I'm going to customize the on click event of this button. That's nothing fancy about it, yeah? So I'm going to create a new method called click play. It's kind of straightforward. So click play, it takes a parameter sender, the object. I'm going to define the contents of this method. So the thing that I want to do is I want to change the view to something else. Let me actually show you how to do another thing, which is how to log something. Logging or just writing things to a log is a standard way to debug all sorts of applications, right? Including games, of course. So the way you can write something to log using Castle Game Engine is you use the routine called writer log. That's defined in the Castle log unit. Now I happen to have it already in the users clause. And yeah, so that's how you can write something to the log. The log will appear here in the Delphi messages. The log will also appear here in the output messages in Castle Game Engine editor. All right. So I'm logging something, but what I really wanted to do now is I wanted to change the view to something else. So inside my view main, I have an instance of something called container. Now container is basically it defines the content that is shown inside your window. In this case, well, the container defines what view is the current view displayed in your game. And I want to change that. Right now I'm displaying the main view. I want to change it into the play view. The play view is contained in the new game view play unit, which I have already added to the users clause. You should add it. And yeah, the view play is just a global variable. It's just an automatically initialized instance of the view play class, which contains the design of your view. I'm saying view word a lot. I know. So yeah, I have just switched the view from main to view plane, and also I have added some fancy logging. Let's see that it works. Okay, so let's press F9. And there we have it. Okay, so now I'm pressing play, and yeah, when I did it, the view has changed from the main view to the play view. And as we can see in the Delphi console, the debug output has also changed. I mean, we wrote something something. Okay, that's our something something. Of course, you can also run the game not only from Delphi, you can run the game also from the Castle Game Engine editor. In this case, it's just going to run the Delphi compiler, the command line Delphi compiler. The result is absolutely the same. Yeah, it's just a matter, where do you want to click F9 in the Castle Game Engine editor or in the Delphi? It's all doing the same thing. Ultimately, it's all just going to run your game, and you can press play, and you can see the log, something, something. Amazing. Yeah, so it works. Okay, now let's jump to I guess the most interesting part, which is, designing our main view for the game. So let's close this. Let's open play. And okay, so what I want to have? Well, first of all, I want to change this plane into a sand. I'm not a graphic artist, so first of all, I'm going to steal a color from from something that has been designed by actual graphic artist. So I have this cool graphic. Here we have already used it for our main menu. I have opened this graphic in GIMP. Now I'm going to use the GIMP like a probe tool that kind of allows me to inspect the colors. So I'm clicking here, and okay, I like this color. It's a color of the sun. So I'm going to copy the clipboard the hexadecimal representation of this color, and I'm going to go to the Castle Game Engine editor, and I'm going to paste it as the color of my sun. Of course, if I would like to, I could also just configure this color using this thing, but I'm not a graphic designer. Okay, I'm just copying the colors. So I have the plane. Is this good enough for a sun? Kind of. Let's just make it a bit bigger. Okay, so it's like this now. Let's also add some additional lighting because this point lighting is kind of dark. Yeah? The point lighting is a very local lighting. It quickly gets dark the further away you are from the point light. So let's add another lighting. It's going to be called the directional light. It's a bit more like a sun, a bit more. So we're going to make it higher just so I can see it. And we're going to rotate so that it actually shines at my level. Let's actually make it even stronger, okay? So this is now my sun that is shining over everything, okay? What's next? Well, I want to have some reasonable camera position. Now, I could just drag around and rotate this camera and kind of observe what happens in this window. Okay, so that's one way to do it. In this case, actually, there's an easier way to do it. I can also just kind of position myself at the design mode to see something, well, what I want to see. And now I can press the viewport, align camera to view. And this will kind of move the camera onto what I'm seeing at the design time. And it's a good enough way for now to position and rotate my camera. What next? I want to have the hero. It's going to be a female pirate character, and I want her to shoot the balls, the missiles, towards the skeletons. All right, so let's go into our data files. Our data files contain something like character an, GLTF, think 3D model. Okay, so I'm just dragging and dropping it onto our scene. And there she is. Amazing. I can always press when I select something in the editor. You should notice that I can press called F, like focus, to immediately like bring my camera so that I can look at the design time at the character that I have selected in the hierarchy. So she has a number of animations. They are all cool, but I really want one of them. I really want an animation that is called Punch. I'm going to kind of overuse this animation for, I'm going to pretend that she's throwing a ball, okay? It's not really an animation of throwing a ball. I know, but it's close enough for my purposes, and I'm not a graphic artist, so I can't do anything better, at least not in 5 minutes. So let's rotate her, okay? She's going to look like this, and she's going just to throw the balls towards the sea. Okay, towards the skeletons, yeah? Let's save the design. Okay, now to make it look better, well, before I add more stuff, I want to actually enable shadows because everything looks better. I mean, you kind of visually orient yourself better when you see shadows underneath things. So let me select a light, one light that should cast shadows, and let me click on the shadows checkbox. Now, for the shadows to make sense, the objects kind of must be closed. That's called two manifold in mathematics. It's called like skin tight or waterproof in well, different terminology. At the beginning, the engine doesn't really know that this particular model is waterproof, but I can tell it that, yeah, I kind of guarantee that it's manifold waterproof by doing this. Okay, and now the shadow under my character has appeared. So I have selected the checkbox called Whole Scene Manifold. And this means that I'm telling the engine, I'm sure that this model has been correctly designed to be able to accept shadows, which means that every edge has two faces, which means it's watertight, to manifold and so on. And now the shadows done by the shadow volumes algorithm work nicely, and I can also kind of see where the character is standing. Yeah, and the shadows are visual cues. They help us to realize what's going on in the three-dimensional scene. Okay, so I have my character. What more? Well, I want my enemy. Okay, my enemy is going to be a skeleton. So this is our skeleton. This is the preview of the skeleton. Well, let me drag and drop it on our viewport. Okay, so it's done like this. And by the way, what is happening when I drag and drop? Well, it's really creating an instance of a class called T castle scene, which is really the most important component in our engine because it's used to display almost everything underneath. So what it's doing is it's actually adding a class called tcastle scene, and it's automatically configuring this class to have the URL that refers, in this case, to my skeleton. Okay, so I could also do it manually by going add the transform scene and then configuring the URL. But of course, it's much easier to just drag and drop things onto my viewport. Okay, so that's a skeleton. Let's make sure the skeleton also casts shadows nicely. Cool. Let's make sure that the skeleton is playing a walking animation. It's walking in place. Later, using Pascal code, we will actually make it walk, well, not in place, but on the level. Let's move it a bit. I think this view is better for moving the skeleton. Let's add another one. I just pressed Ctrl D to make another skeleton, a copy of the skeleton appear. Okay, and another Ctrl D, another copy of the skeleton. Cool. So I have three skeletons. And now my character is going to throw some stuff at them. Let's add also some interesting environment. So let's go, and this those assets, the pirate kit from Quaternius, then contain a number of cool assets to kind of fill the environment with something interesting, okay? So, for example, let's add some palm trees. Let's add a palm tree there. Let's add a palm tree there. Let's add some rock. Let's add bones. That's good enough, yeah? Let's actually add some cliffs. The cliffs are nice to kind of delimit your area because they are big, okay? So I want some big, big cliffs to be present. And there we go. Okay, and I think that's good enough. Actually, this that's good enough. It's just a decoration. I only wanted to have some decoration, and that's good enough. And again, I need to kind of remember to tell the engine that yes, I'm sure that this model has been properly designed so that it's watertight and I can use it to cast shadows. All right, so that's my view. I like this view. I'm going now to make code such that this character is actually throwing balls and is able to well, kill those. Well, yeah, kill those skeletons. Okay, let's move the character further a bit. Make it a bit more difficult. Let's again make sure that the camera is at the right position. So I'm going to again use actually viewport align camera to view, and that's a good view for our player. Let's save the design, and let's also assign, while we are still here, assign the useful names for our components. Okay. So I'm going to call this character the player. Okay, that's a reasonable, boring and reasonable name. Now here I'm going to call those guys the enemy 1, enemy 2, and enemy 3. All right. So I have my basic design ready in Castle Game Engine Editor. Now the next thing I want to do, okay, so I have the views, I have the scenes. Now I want to actually have the rockets. Now I'm not going to design a rocket. I'm just going to use a ball, okay? So the sphere for a rocket, okay? So how do I go about this? Well, I mean, I could just add a sphere to this design, yeah? I could just go items, add transform, sphere. Yeah, but I want to spawn this sphere by code. And I want also this sphere to follow the laws of physics. So I cannot really just, place one sphere in this design. I want a sphere that is available for code to spawn it multiple times. Okay, so what I'm going to do is I'm going to use something called reusable design. And for this, I'm going to create a new transform. It's going to have so let's click on it. Let's see what happens. Yeah. So the thing that happened is that our design has changed. Now we have created a new design that's going to contain new Castle Game Engine component. It's just the Castle transform. So it's an empty transformation. It's just expressed as something that has a translation, scale, orientation, rotation, and it's nothing. Yeah, it's nothing initially. I want this to actually be two things. First of all, I want this to display a sphere, and second of all, I want it to have a physical properties, which means that I want to assign here a collider. A collider is something that tells the engine how does this thing collides. So sometimes how the things collide is different from how the things look like for the efficiency optimization purposes. In case of sphere, well, it's going to look like a sphere and it's going to collide like a sphere. Okay, so nothing fancy. So I'm just adding here transformation sphere. Let's make this sphere red. Let's make it red. Okay, let's start by a reddish sphere. And so that's how it looks like. Now, how does it collide? Well, it collides also like a sphere. So I'm adding a behavior, physics, collider, sphere, and there we have it. Okay, so that's our sphere. I'm also going to name this rigid body something, well, something that I will remember, okay? I'm going to call it the main rigid body. The rigid body component is something that controls how the component, how the thing, in this case a sphere, how it's affected by collisions and physics. And I'm going to need this rigid body component because I can use the rigid body component to actually send something flying. And when we spawn those missiles, we want to send them flying towards the skeletons, right? So I'm going to need this component. So remember this name, main rigid body. And I'm also going to configure the radius of the sphere because it's going to be probably a little too big for my usage. Okay, let's make it like this. I'm going to save the design under a name that I will be able to later load and use. So I'm going to the directory of my game, the documents, custom engine projects, pirates, data, and I'm going to call it the missile. Okay. Now the missile is something that is now available in my data subdirectory right here. I can always go back to it. I can edit it. I can change it. Okay. Let's actually check out how it works. If I would just place it manually in our game view play, then the missile will look like this. Okay, looks reasonable. Yeah. Now imagine that my code is doing this and the missile flies forward. Okay, cool. But I don't want this. I mean, I would want to use Pascal code to spawn it. Okay. I've only just done it to make sure that it looks reasonable. Okay. So the title of the talk, coding. So let's jump to the Pascal coding of everything that I have now visual design. Okay. So first thing, I want to be able to spawn this rocket. I want to be able to spawn it repeatedly, often. Okay, so how do I do it? Well, I can use something called Castle Component Factory. This is a way to load the design and later be able to repeatedly spawn it to perform, well, basically whatever I want. Okay, so let's go for it. So I'm going to use the unit called Castle Component Serialize. And I'm going to have something called missile factory of the class the castle component factory. Okay, cool. Another thing I also want to have is I want to have a timer because I want to spawn those missiles just repeatedly. Okay, so let's also create a timer. The timer is just the castle timer in our case. Okay, let's initialize all those things. So I have a timer. Let's create it. So let's see, custom timer. Let's create it. What to assign as the owner? Each component in Pascal has an owner. The owner, when the owner is freed, the component is also freed. What could I use for components that should stop existing when the view is no longer visible on the screen? Well, there's a very useful component called free at stop in Castle Game Engine. And this means that if the play view will stop, for example, if we will allow the user to go back to the main menu, yeah? So if the play view will stop existing, at least stop being visible, then the free at stop, the components owned by free at stop, they will be freed. And that's cool because we want the timer to only exist as long as the play view exists. Okay, so that's our timer. Nothing interesting here. The timer has some interval. So let's say that I want to spawn the ball every half of a second. The timer has also a method that says, well, I mean, an event on timer that determines what happens when the timer actually occurs. Okay, so that's my do timer method, and I'm going to implement it very, very soon. Okay. Uh, so that's yeah. So I'm going to film in a second. Now another thing that I want to now have available is I want to have available my factory for running the missiles. Okay, how do I initialize it? Well, again, I go to the start method. I don't need this code, this comment anymore. I'm going to create it. Again, it can be owned by free at stop component and the missile factory. Well, I want to load like a template that I can spawn multiple times using this factory. So I want to set the URL of it to the file that represents my missile. So I know the name of my missile. It's called missile.castle-transform, and it's in the data subdirectory. When something is in the data subdirectory, I can use a special URL protocol, Castle Data in Castle Game Engine, and everything else I type here is just a file name. Nothing magic about it. Yeah. So here I'm just typing the name of the file of the missile that I have now created. Okay, no? So I have a missile, okay? I have a factory to make missiles. Now, every time the timer happens, I want to create a new component. I want to create a new component that shows the new instance of the missile. Okay, now I want to, well, in the beginning, okay, so the new missile, the new sphere is going to be just owned by my view. And I want to also, so I have an instance of the missile like this, component load, like this. Okay, so now my factory has created for me another instance of a missile. I know it descends from the Tcastle transform class, So I can just declare it, I can just typecast it like this. It's going to be useful for me in a second. That is a pcastle transform. Okay, so now I have a missile, and now I want to add this missile to my world. What does it mean? Wait, I have a viewport. I have a viewport. Let's assign some useful name for it. Let's call it main view. Okay, so I want to add this missile to the main viewport items. And that's going to achieve, well, the same thing that we have done visually like a minute ago, yeah? I drag and dropped the missile and I placed it inside the main viewport items. So now I'm just going to do exactly the same thing from code. And this way it will happen, well, repeated, yeah, every 2 times per second, okay? All right. And let's add a unit so that this class is defined. And now let's define in the published section my main viewport. The class is the custom viewport. Let's make sure that the unit is properly declared. Okay, so now main viewport items add missile. Okay, cool. Now, is this everything? Well, not really, yeah? I mean, okay, we have added the missile. Where should this missile be? Well, it should be exactly where the player is. Actually, not exactly where the player is, yeah? It would be nicer if actually the player has had like an additional transformation. I mean, because the origin of the player is here, at the feet of the player. And that's normal. That's how you design the 3D models. I mean, the character is standing on the ground. But the missile, I don't want the missile to shoot at the ground level. I want the missile to shoot at the height of the hand of my character. So let's add another transformation here. Add transformation. It's not visible for the player, just the tcastle transform class is just a transformation. It's just a translation, rotation. It's not visible for the player by itself. Let's call it the hand, okay? The missile shooter, okay? And I like the name, missile shooter, okay? So this is our component, and I'm going to place it a bit so it kind of matches the animation of my character, just a little bit. I know that, well, it's not even an animation or throwing the rock or throwing the missile. I'm going to pretend it is. Okay, so we have now missile shooter. Okay, so the missile shooter can determine the position of my missile. It can also determine actually the direction of my missile, because initially, if I just place a ball here, well, nothing. It will just be in place. Then if I enable physics, then the gravity will make this ball fall down and nothing. That's not a missile. That's just a ball that falls into the ground. I don't want that. So I want the missile to fly in a given direction. As you can see here, the blue arrow looks tempting. The blue arrow is the direction I want the missile to take. Okay, so what do those arrows means? Well, those are the axes, local coordinate system of my missile. The red axis stands for X, the green axis stands for Y, and the blue axis stands for the Z axis. Aha! So the direction that I want my missile to take is coming from the Z axis of the missile shooter. Okay, so missile shooter. Let's declare the missile shooter. Let's define the necessary unit in the interface section. All right, so now I have the missile shooter, and the missile shooter should determine the position and the direction in which my missile should fly. Okay, so the initial position of the missile. Okay, so I have the missile. It has a property called translation. This is the position in layman terms, let's call it. So the missile shooter will just take the position of the missile shooter. And now it's important. I mean, there are there's a number of coordinate systems in Castle Game Engine, in every game engine actually. So the thing is that, the things are transformed. So you have one thing that has a translation rotation, and it's under another thing that has translation rotation, and it can be within another thing that has translation rotation. And this is actually visible in Castle Game Engine hierarchy. Like a missile shooter is actually a children of player, which is actually a children of items. So you want to always be aware in what coordinate systems are you thinking. In this case, I have added, are you thinking? I mean, in what coordinate systems do you want to specify something. That's a better way of saying it. So I have added the missile to the items of my viewport. So I want to think in something called word coordinate system. So for this, I want to make sure that I take the translation of the missile shooter in word coordinates, and I take the direction of the missile shooter also in word coordinates. So missile shooter word translation, that's what I want. Now I have positioned the missile correctly. Now the initial direction in which I want the missile to go, okay, let's just call initial dir for a second. How do I calculate this? Let's just declare it. Okay, so now I have my missile shooter, and I can say I want to transform local to world direction. And now I know that the direction that I saw, it was this blue arrow, okay? So the blue arrow is this vector, okay? 0, 0, 1. I want to transform this vector from local to world coordinates, and that's the initial direction in which I want to send my missile, my rocket flying. Okay, what more do we want? Well, now I have just set this local variable, okay? I want to access this component inside the missile, this rigid body, that will allow me to actually tell the rigid body, in which direction you should go. Let's go for it. So the way to do it is when I instantiate a component. I mean, there are actually two ways to do it in Castle Game Engine. The way to do it that I want to present to you is that when you spawn a component using the factory, you can also pass something called the design, the class that contains the design of your object. The idea is that the published fields of this class, they will be automatically initialized to the corresponding names of your design. So, long story short, and well, making it more concrete that I'm talking. So the missile is a component called main rigid body. So I want to declare a class called T missile design. This has to descend from the persistent class or one of the descendant of the persistent class. Just T persistent is good enough for me. And I want to have in the published section of this class, I want to have something that is called the same. So main rigid body. Good. Main rigid body, T-cast rigid body. And I'm going to need actually this missile design. I'm going to create a temporary instance of this class. So I'm going to go like this. I'm going to free it immediately. So that's good enough. That's good enough. I don't need this. Let's call it at the end missile design. Okay, okay, and now okay. What did we achieve? Well, now I have missile design dot main rigid body, and I can do whatever I want with the rigid body initially, which is, as we already foretold, I can send it flying. There are a few ways to send flying something in Castle Game Engine. You can send something like an impulse, you can add a force. For here, I'm just going to set the initial velocity of my physics thing, of my missile, and I know what should be the initial velocity as the direction I have, yeah? I can actually make it larger, yeah? Let's say like 100, okay. Is this everything? I know there's one thing missing actually, but let's try it out, okay? Let's try out what happens. Let's add the unit that has the free and new routine. Actually, yeah, I forgot. No, it's a persistent. It's not a component. I don't need an owner. Yeah, let's see what happens. All right, play. Okay, so we have the design that we wanted, but the ball is not actually spawning. Why? Because the timer, I did not actually add the timer to my view. So the timer, well, it doesn't really do anything. I mean, it never actually happens. The timer must be added to the view to receive the events about the time passing. Okay, so the character is shooting missiles. What more do I want to do? Well, first of all, well, right now the character, I mean, those missiles actually cannot hit anything because the missiles are the only object that has rigid body component in my world. So they will always just fly into the infinity. So yeah, not very interesting. Um, and so another thing I want to, well, I want to define the rigid body components on all my objects, but well, I also want to actually allow you to move the character and also thus move the position from which you are shooting the ball. Okay, so let's do the second thing first. So let's allow the player to move the character that is shooting the balls. How do you go about it? Well, you have really two methods that you can implement in Castle Game Engine how to handle the player input. First of all, you can override the press method, which happens when somebody presses a button, but also you can just handle input in the update method. The update method is kind of called all the time when your game is processing. The update method is called more or less 60 times per second, but you're not really sure. You cannot be sure how often is it called. You should use seconds past to know how often the update method has been called. But the point is, the engine makes sure to run your update method kind of as often as possible. Well, not too often, yeah? 60 frames per second, unusual, yeah? So you can, in update, you can observe, did the user press some button? I mean, is the user right now pressing some button? It can be a mouse button, it can be a keyboard, key on the keyboard, and if the user is pressing this thing, then do something. Do what? For example, move the player. Moving the player will also move this missile shooter. Yeah, that's why I have done this. I have placed this missile shooter as a child of the player. This way, if I move the player, I'm also moving the missile shooter. Okay, cool. So, how do I move the player? Well, first of all, let's try to do it well visual in the editor. What I would do in the editor to move the player, I would just drag the red arrow. And the player is just directly placed under the items, so I don't even need to care about those coordinate systems. So I can just change the player translation. I can change the X component of the player translation. That's how you move the player. And it's really that simple. So let's check if the container pressed. Let's say that I want to react to the left key. Then the player, it's called just a player. The player T-castle. I could also alternatively, I mean, I could also declare it as T-castle scene because it's really a T-castle scene class, but I don't really need the T-castle scene class features. The ancestor of T-castle scene is T-castle transform. That's good enough for me. I don't need anything more. Okay, so if this, then multiplayer. Well, translation, translation minus vector, and I want to move it, well, I want to use something like move speed 0, 0. Okay, so that's a vector that has, well, it has 0 on the y and z axis, and it's going and it's telling, okay, change the x axis of the player translation. And that's all I want to do. Of course, when you press the right arrow, I want to do, I mean, the other thing. So I want to do this. I want to go in the other direction. And what more? I want to actually define the move speed. I don't know. Like, let's actually put 5. So it's going to be 5 units. I want the character to move by 5 units per second. Okay, let's see what happens. Let's run it. Okay. Whoops, that's way too fast. Okay, I know what happened because as I told you, and you should already know too. So the update method it occurs 60 times per second, more or less 60 times per second. So this means that when I'm holding the left arrow key, this line is executed well 60 times per second. That's not what I want. How to solve it? Yeah. Well, the wrong. First of all, the wrong. Don't do what I'm doing. Yeah. So the wrong way to solve it is to assume that your update method is going to occur 60 times per second. So I could do this. It's a wrong way to do it because you don't really know how often the update method is going to be executed. It depends on your computer speed. It depends on the user's computer speed, the user that will play your game. It depends on their computer speed. It depends on the graphic card. It depends also whatever else you are doing in your game that could kind of cause an overhead. Which means that the frames would be rendered longer. It would take more time to render a frame. And also, this number can change during your game. So don't ever, ever, ever assume that the update method occurs 60 times per second. That's just a way of thinking about it, yeah. But it's just an average, yeah. But don't ever assume it, or your game will be just wrong on other people's computers. What you should do is you should just multiply. You should multiply whatever you're doing in the update method. Like remember everything you're doing in the update method. It should be multiplied by the seconds passed. Because this way, whatever effect you're doing, well, it's going to actually take into account how much time has passed between the previous and the next update event. And now what should happen is that the unit, the player character, will move by 5 units per second, exactly per second. And let's see if it's better. Okay, yes, yes. So that's what we want. Okay, so the player is shooting missiles repeatedly. Okay. What else do we want? And by the way, those missiles they fly into infinity, but you don't see it because they actually go underground because the gravity works. That's actually okay for this game. Yeah, they fly far enough. Okay, so we want the missiles to actually hit something. For example, we want the missiles to actually hit the skeletons. I mean, the skeleton enemies and also this skeleton decoration. We want the missiles to well behave in a fun way. That's a short way of saying it. Okay, why doesn't it now? Because the other things like the skeletons, they don't have rigid body and collider components. Okay, let's go ahead to the editor and let's add them. So I have an enemy. I want to add here a behavior, collider, box. And I'm just going to do it for all my skeletons. Physics collider box. The default box collider, it will automatically have a reasonable size. If I'm not sure what is the size, I can always check the show colliders many item. Okay, that's what you see now. That's how the physics is actually seeing your game. It doesn't see the mesh of the skeleton. It's way too complicated. Well, it is way too complicated for this game to consider for collision detection. For this game, just a bounding box of the item of the skeleton is a good enough approximation. If the ball will hit this bounding box, we want the skeleton to fall down to the ground. Okay. So that's about our skeletons. Should we add some more? Yeah, let's at least, for example, let's add the behaviors, the physics behavior to the cliffs. In this case, we can actually assign to them the collider mesh. The mesh is a static collider, which is good because those cliffs don't move at all, and it's only just a decoration. Really, we just want the ball to like realistically bounce off those things. Here both mesh and box should be fine. I'm going to use a box just because otherwise I feel that you would almost never hit those bones. Okay, let's add the physics behavior here. Again, just a mesh. Go ahead and, of course, you can. I mean, you please improve this demo. One more thing, as I said, like those balls, they actually fall under the ground. Why? Because the ground has no collider. Okay, but then the ground, it's a plane. It naturally has a physics collider plane. The physics collider of a plane is actually like an infinite plane. So it's displayed as a plane with a finite size. It's displayed as a plane with 100 units. But the physics collider of the plane collider, it's actually simulating an infinite plane, which is actually very good for what we're doing because it's a ground. And if you want a ground, yeah, plane collider is what you should use. Okay, so I have only just changed something in the editor. Let's run the game. Yeah. Each time I change something in the editor, remember to save the design, of course, because then the design will be loaded by the game at runtime. Okay. Uh, okay. Of course. The balls don't get through. Uh, Yes. Let's call it a feature. Let's call it a feature. Yeah, that's what we wanted to happen. Amazing. And now I can bounce those skeletons. And the balls. I think I didn't assign a mesh collider to one cliff, but I did assign a mesh collider to this cliff further down. Amazing game, 5 stars out of 5. It's not really the end yet, because I wanted that if the ball hits the skeleton, then the skeleton dies, not I don't know, something flies like a box further away. So I want the skeleton animation to change from the walking to death when the skeleton is hit. I also want the skeletons to walk. So we have those two tasks to perform. And that's going to be everything that I wanted to show in this demonstration. Okay, so how do I make the skeletons, die when they are hit instead of being, moved by the physics? So first of all, I don't want the skeletons to actually be affected by collisions in the way that they are, which means that I want to detect collisions on the skeletons, but I don't want them to bounce off when something hits them. So I'm going to uncheck the dynamic checkbox of a skeleton of the three rigid bodies that belong to the skeleton. Second of all, I'm going to actually assign an event to them, to the rigid bodies of those skeletons. I'm going to assign an event that detects when has the skeleton been hit by anything, actually, in case of our game. But to make it correct, you would make it when is the skeleton hit by a rocket. Okay, so let's call it enemy rigid body 1, enemy rigid body 2, enemy rigid body 3. I will have to access those components now. Okay, so I want my enemies. And 1, 2, 3. I could do it. I'm going to do a little bit manual here stuff for those 3 enemies, but of course, in a real game, you would manage them better. You would put them in the table, maybe you would spawn them by code. Yeah. So right now, I'm just taking a shortcut because I only have 3 enemies. So I'm going to take some shortcuts now. How to make them actually behave correctly. Let's declare a unit that contains the castle scene. Okay, cool. Now, if the enemy is hit, I want to detect it. So that's why I needed the access to the rigid body component of my skeletons. Now the rigid body component has an event called on collision enter. Okay, so let's call it skeleton 1 collides. And do I want to do it? Yes, I think I want to do it. Yes, you can solve it in a number of smart ways. I'm not going to be smart now because I feel a bit that I'm going out of my allocated time. Okay, so not being smart. Okay, so we just assign a different event to each skeleton. Okay, so I now need 3 events. What did I call them? Skeleton 1 collides. Good enough. Okay, I'm going to make amazing implementation of them. What is the amazing implementation? Well, if the skeleton 1 collides, then I'm going to change the animation of the skeleton. How do I change the animation? Well, the enemy 1 has an out animation property called walk. I can change it. For example, I can change it to death. I can change it by just assigning something to the auto animation property. I can also call the play animation method. It doesn't matter in this case, actually. So it doesn't matter. The other thing I want to do is I want to actually also deactivate physics for things that have been already dead. I want the bullets to fly through the dead bodies because that's just going to look better. That's the usual trick in games here. You don't want the dead bodies to collide. Sounds morbid, but it works. Okay. Let's go. Okay, so the enemy. First of all, play animation. Oops, sorry. First of all, I want the enemy to play animation called death. And this animation is not, oops, this animation is not looping. Okay. And the second thing is I want the enemy rigid body one to actually stop being relevant for the physics detection. Yeah, and as I say, I'm doing it in a stupid way. I could do it so much better, but I'm going to do it in a stupid way. And don't do it. I mean, make a table, make a list, make a design that contains them. I mean, you want to have configurable number of enemies in your game. Let's see how it works. Okay. And there we have it. Okay, so the skeletons die. The last thing, the game is too easy. Yeah, the skeletons were supposed to walk, and they are not walking right now. How am I going to make the skeletons walk? Well, I'm going to use something called the behavior. Behaviors, it's something we actually already used in our in the design in the editor. Behaviors allow to you to enhance how something behaves, allow you to enhance how what the transformation is doing. The idea is that if you don't want to display something, but you only want to enhance how something reacts, behaves, walks, then use the behavior class. It's a nice way to enhance the behavior of the parent object. And the bonus, I mean, the behaviors can be added and removed at runtime, which means that, for example, I can add the behavior walk to a skeleton, but then when the skeleton dies, I can remove this behavior because that skeleton should not move anymore. Okay, so how do we define the behavior? Well, we use the unit called custom behaviors. Okay, and we define a new class. Okay, let's call it enemy walk. The class will descend from the custom behavior class. Okay, the thing we really want to update there is just the update method. Okay, now the enemy is the parent of this behavior will always be a skeleton. I know that. That's how I'm going to use this behavior, so I know that. Okay, so take the parent, move the translation. You know what, just a moment, yeah. So translation, move it by 2 units per second. Actually, no, let's make it half a unit per second. That's it. That's it. Except now they are going to walk into infinity. Let's make it such that if their position is too big, then, well, just teleport them back. Now I should add this behavior in the start class to my component. So I'm just doing one, add behavior, and I just create a new instance of this. And I just do it for all 3 enemies. Almost everything right, except I should also remove this add behavior from the dead bodies. Let's go ahead and actually, when the enemy is hit, so here I want to find enemy one, find behavior, and walk, and I'm going to remove. So enemy one, remove behavior, walk. Now, I already regret doing it in this stupid way that you will not force me to make a copy paste of this thing. That's, I guess, what comes with trying to do the demo live. I want to be honest. So, well, as I say, I mean, I regret doing it like this. I should have a table for those stuff, yeah? But then, well, yeah, I will manage. So don't do it in your code. Make an array, make a list, pass this instance of the enemy in some smart way to your callback. And in particular, you can actually, the collision details contain the transformation that you are working with. And from this transformation, you can derive everything else, like the rigid body, like the behaviors, every behavior that has been contained in the rigid body that is collided. So you don't do what I'm doing. That's a short version of this talk. Let's see if it works. Okay. Here I decided to add a class. They walk extremely slowly, but they walk. Okay? Make it better. One way to make it better, for example, make the skeletons walk in more interesting patterns. Another way to make it better, place some colliders like palms, trees, that actually prevent you from shooting those skeletons so easily. Because they didn't stand a chance right now. Okay. So another thing I want to talk to you about was the C++. We don't support only Pascal. Thanks to the Delphi and C++ builder, very close integration. You can also use C++ code with essentially the same API that you know from our Pascal presentation. They are just the same classes, yeah? So let's actually take a look at how it works. Okay, so I'm opening the project in the C++ builder. Okay, we're leaving the Pascal world. Hold on. And now let's open a sample project using the C++ builder. We have examples, Delphi, C++ builder. And let's go for the window example. Okay, and that's a C++ code. I didn't actually show you this, but it's similar to the analogous code in the Pascal examples. And here we have the view main. Oh, the same thing that we know, just in C++ now. And yeah, it's the same thing that you know again. So you have this game view main header. You have this that in particular has a published field that defines stuff that you want to access from C++ code. And you also have the game view main C++ code that says what happens. For example, here's the start method that determines what happens when the view starts. And here, you know this already just from Pascal, yeah? So you can assign some events to buttons to determine what happens. Here you can operate on components, yeah? Tcastle scene is a Pascal and C++ component now, and you can use the URL property of it to change the model. And here you know the tcastle scene component translation property. We change it, we add a new vector to it. It's exactly the thing that you saw a few minutes ago in Pascal. Now it's done in C++. It looks the same. So now I have just clicked a button and I changed the scene URL to a banner. Now let's execute this code here. So move scene up. So what it's doing in C++ is this. So it's moving the scene up, and the scene has a, rigid body and a physics assigned to it. You already know them from our past presentation, past 5 minutes ago. So C++ builder, Castle Game Engine, physics, it all works. It's really the same API, just expressed in C++ now. And that's actually everything from the leaf that I wanted to show to you. Again, go ahead, check out the project, do it yourself, have fun. What about the engine? What more? So, first of all, if you like what I'm showing, if you like what you're going to do with the engine, if you like the possibilities that it's giving you, please support us. I'm working full time on the engine for a few months now. I'm counting big on the engine, and then, please support us. It basically makes the engine development possible, and I want it to be possible thanks to you, thanks to your support. So if you can, please support us on Patreon. We are also looking for cooperation with companies, consulting, dedicated features, extra platforms. If you need something that aligns with our vision, but we have a big vision, then go ahead and contact me. We're open to company cooperation. We're open basically to having this sustainable. Now the plans. So first of all, before this video will actually going to be published, I hope to release the new version of the engine with a long number called 7.0 Alpha 3. And this is a long version number because it's actually a preparation to a big engine 7.0 the end 7.0 release is going to contain a few more features than we already have, in particular Steam integration, new material components that you can use from the code and editor, really comfortable way to, for example, make some mirrors, and in general make some colors, textures from the editor and from code. And then new navigation components that also follow the physics and are a bit more better organized than the current navigation components. New targets after the 7.0 release. I mean, we have a lot of planned features, but I think actually two targets are very interesting. So first of all, we want to add a web target that's going to use actually the Free Pascal compiler WebAssembly backend. But you can develop your games in Delphi, you can recompile them in Free Pascal. We support both of those languages, so I'm pretty sure that the web target is going to be interesting to you as a Pascal developer or whatever compiler you prefer to use. And then another target, VR. In particular, I have an Oculus and Oculus Quest. And so, we want to make our engine available on the VR devices because they are cool. They offer a new type, immersive type of a gaming, and we want to support them. More platforms coming to Delphi. This is, I guess, in particular important to you, the Delphi people. I mean, I know that the platforms we support right now with Delphi are not, well, it's not a full set. So first of all, I want Delphi to be supported for, Castle Game Engine, and Delphi to support Android. I guess the next one will be macOS, iOS, but definitely, more or less definitely, Android will be the next one that we will do. And there's much more that I can talk about. It's all available on our roadmap, which is probably the longest and most actively edited document on our website because it contains a lot of my thoughts about what I think should happen in the engine, what I think should have the best impact. And I go ahead, visit this document and tell me what you think, what would be the features interesting to you. And thank you. Let me get my face out of my email. Contact me, visit the engine, download it, everything I've shown you, completely for free, available now, downloadable now. Go ahead and check it out, basically. Make a game, make anything. It's useful for visualizations, for industrial visualization. You can place a component inside the Delphi VCL or FireMonkey form, or you can just make a full screen, window with only the engine, as you saw kind of in this example also. More or less. So the engine is useful for games. The engine is useful for visualizations, 3D, 2D, scientific visualizations, and fun visualizations. Try the engine. See how you like it. Let me know how do you like it. Here's my contact. And thank you. Thank you very much for listening. Thank you.
Fantastic. What an excellent session that was. Michalis, excuse me. Oh dear. It's very horribly hot in Dallas and it's killing my throat. Michalis is absolutely brilliant. I love his presentations. I'm pleased to say he is live in the studio with me. Hello, Michalis. Or should I say Dzień dobry? Because I found out that you're Polish as well. So we had a little chat. Yeah, we had a little chat behind the scenes, didn't we, and saying that the Polish are taking over the world bit by bit. So,
My name is a bit confusing. It's a Greek name, but I'm Polish secretly. Okay, it's no longer secret. It's public.
I have to say, I always thought you were Greek. I have to say, so there you go. Yeah, well, there you go. I mean, obviously we're very biased towards the Greeks because of Delphi and Athens and that, but I have a personal spot for the Polish as well. Lots and lots of comments and appreciation and stuff like that. One that I wanted to call out was this one from John Potter, who said he was loving this. So a lot of love for your session there. He wasn't the only one. There were a bunch of others as well. I starred a few of them. I'm going to put up here on the screen a QR code. If people scan that with their devices or whatever, it will take them to your site directly. And Patrick has also been making sure, as he always does, that people know about your other things. So Patrick.
Thank you very much. Thank you for sending all the links. Thank you.
Yeah, well, I mean, it's a give and take. You guys come and present your stuff, and also what you do for the community, Michalis, is absolutely astounding. every time I see a presentation, I've seen a few of your presentations, and we've been on a few webinars together before, and every time I'm amazed at how much work goes into what you do. It's not a toy. It's really astounding. I mean, how many hours do you spend coding on this? It's got to be hundreds and hundreds, I would have thought, maybe thousands. Yeah.
That's most of my life bit now. I can't do anything else.
Yeah, well,
But I
there you
love
go.
it. I love every minute of it.
Yeah, me too. I mean, I love being a developer, and I do what I do because of not just because of Embarcadero, but because I really enjoy. I've been a developer for 40 years. I still love it. I could be off doing management and things like that, but I like doing this. And for those of you that are watching, I'm going to stare at my camera and make sure. If you like what Michalis did, go to Patreon and support him. This is how to keep open source open, but also to encourage Michalis and make sure that he can afford to keep working on the project, because it's things like this kind of support. It doesn't matter how much it is, like tick away and, avoid a few expensive coffees if that's your thing, or take one less takeaway and put it into, funding some open source software, because what you do, Michalis, is mind blowing. I every time I'm like, wow, this is great stuff. It's really good. So Patreon, and what was the other? Oh yes, I put another QR code up as well, which is that's the website at the moment. There you go, that one, and this one is for the GitHub. So if they go there, then they can also find the example site as well. So great stuff. Some of the questions that we got, which I think you answered, but I think it's probably just as well for me to answer it. The first one, which I thought was funny, was Werner very quickly spotted that you'd made a little bit of a boo-boo there on a file name. Aren't people weird? They notice these things.
I cut it out later from the video, the part where I'm like clickbait, but you got it. Okay, kudos.
Yeah, you can never get away with anything. You know that? They spot absolutely everything. Yeah, I mean, you did copy it. And as you said, you caught that, right? So I did actually change it as well. And Nigel asked this question. I didn't see if you answered it. In the video, when the characters are kind of cycling through, I think he was saying, can you stop that movement where they're doing that whilst you're designing, or is that something that is part of the engine?
Yeah. I did not answer this question in the chat because I'm not 100% clear, to be honest, what is the question. I mean, just to expand, I mean, Nigel, go ahead if you want to post and follow up to this. I can answer better. From what I can answer right now is, for example, of course you can stop moving the character, you can stop doing those updates or the translation whenever you want, based on any condition you want. You can also stop animating the character. The character that I've shown in this video is a GLTF character. It's animated using the skinned animation technique in the GLTF. You can change this animation to anything else at any moment you want, and you can stop this animation at any moment.
I think you meant during the preview, when you were going into the collision detection and you were putting the wireframe around the enemy so that the missile could hit the characters are doing that whilst you're actually in that section. I think that's what he meant, because that's when he put that message up. Am I cutting out? You can't hear me?
So
I'm going to sing whilst we
So I'm very sorry. Can you repeat the last sentence, because I had the Bluetooth headphones and somebody just called.
Yeah, that's why you looked cross. I know exactly how you feel. Yeah. So what he meant was, when you are in the preview where you're putting the wireframes on for the collision detection, and where you're moving around the physics of the weapon, the characters are animating like that. And I think what he meant was, can you turn it off so they just stand still? Because he found it a bit irritating that they kept moving whilst you were trying to put that wireframe up. It's not a big problem, but I think that's what he meant. Yeah.
Yeah, so two things. I mean, first of all, you can change the time scale of the viewport to 0, and then essentially everything stops. The other thing is you can kind of ignore this problem also, because what happens at runtime, we don't. I mean, at design time, we are kind of aggressively updating the collisions, the sizes of your collision boxes, because at design time, that's probably what you want. At runtime, when you actually run the game, we don't do this, because you probably don't want the sizes of your colliders to change dynamically, because then everything goes crazy, essentially. So this does not happen when the game runs. If we would activate the collision visualization at runtime during the game, you would see that the collision box is just encompasses the whole box where the animation can be, and it does not change at runtime. So at runtime, I mean, the skeleton is really stupid thing at runtime. It's just a box. That's what the physics considers it as. It's just a box with constant size, and so it kind of works. So you can change the time scale, or you can ignore the problem.
Yeah, so the answer is yes, you can do something about it. He needs to read the documentation. That's what he needs to do, and join your Patreon, and then he can ask some questions as well, right? I think that's how that works. What else have we got? Yes, I'll just put Patreon up again as well. So this was another question. I actually know the answer to this, and you did answer this question as well, which is the Castle Games editor and the components compatible with VCL or FarmMonkey projects? Can we add a CGE scene in a classic project? And like I say, I do know what the answer to this is, but I think it's up to you to answer it.
Yeah, I can actually do it, because the answer is obviously yes. I can actually do like a few second demo of what do I mean.
Cool, go ahead.
So let me just share the screen.
Yeah, and then I'll switch the screen on so it works. I'll hide this question because otherwise.
Okay. Tell me if the screen is like online, visible to people. Oh, I see myself recursively. Okay, so I think with this it's on. Everybody sees it. Okay, cool. So let me stop being seeing recursively. Okay, so this is the Castle Game Engine editor, and this is the Delphi. So yes, you can put the. I mean, what you have seen in this recording is that I use something called tCastle window. This is the default class in Castle Game Engine to show your window, and it does not depend on the VCL. It does not depend on the FireMonkey. But if you want to, yes, we have an alternative component called tCastle control. And this one is something that you can just place on a FireMonkey form, or there's a version that you can place on a VCL form. And yeah, I mean, it looks like this. I mean, at design time, you don't see any rendering, but it's just a regular thing that you just see in your project, and it's just a tCastle control component that is available in Delphi components right here. So you can also have as many of them as you'd like to on your form. And then I mean, the rest of this form, it's a regular FireMonkey components, yeah? So some buttons, some memo, and then it's simple, yeah? And then when I run it, so this is what I see, yeah? So this is the regular FireMonkey memo, buttons and everything. I can even switch stuff here. And here inside, this is the tCastle control rendering. And I can configure what is visible here. I can configure it using Pascal code, and I can configure it using the editor. As you can guess, this was like my theme during the entire presentation. So I can also open this project in Castle Game Engine Editor. I can go to Data, Test 3D, and there it is. It's exactly the same. Yeah? I mean, I can even like prove it. Yeah. So let me make a lot of those barrels. Okay. So this is what I have just designed in Castle Game Engine Editor. I can do design, save, and now let me just run this project from Delphi again, and it will just load the new design from the editor. Okay, yeah, physics works on them. That was actually correct. What happened? Yeah. So you can design things in the editor. You can put them in like a small frame inside your FireMonkey or VCL form. That's all good. Essentially, the choice is yours, whether you want to design the user interface, like I guess the things that like surround your game world. Do you want to design them using FireMonkey, VCL, or do you want to design them using Castle Game Engine user interface components? And you can mix and match. freely. It's all
Yeah,
available.
and
Yeah.
that actually leads me to a question then. Roughly how much, if I had a regular app, let's say it was a business app, but what I wanted to do was something cool, so I wanted to have a splash screen or a credit screen and have it doing some animations. Roughly how much, I mean, I know this is going to be a kind of elastic question, but let's say it's not too complicated. Roughly how much would adding the Castle game engine to my app add to the overall size of the application? Is that something that's
You mean the exercise?
yeah,
Last time I measured it was, I think, 7 MB. That's not
7?
too big and not too small, not too large, not too big, not too large, not too small, I'm afraid. Yeah,
So
it's a
actually
lot of
it's
classes.
nothing, because I mean, if people added like an animated GIF or something like that, it would probably be roughly the same for a couple of seconds of
Yeah,
animated GIF. So
yeah,
it's
yeah.
actually very, it's very
Your data is more your problem. Sorry.
yeah. So actually it's not a lot, and I think that's interesting because someone was asking me in a different session. They were talking about your session, because I think I was introducing it, saying, hey, we've got Michaelis coming along with the Castle game engine. And they said, oh, can it only do games? And I said, no, absolutely not. I mean, that's what it's designed for, but actually it could be anything. If they want to show some graphics, and particularly if it requires physics, where something is going to bounce, or there's a bounding box, so you can't drop something on something. You say, oh no, the physics will not allow you to take this object and put it on top of another object, because I don't know, it's a flow chart, or I don't know what it would be, but actually they could use the Castle game engine for that. And that is actually very interesting, because what you've done is create such a powerful graphics engine there with a fairly easy to understand interface. I mean, it's not, with all games, it's never completely easy. There's you've got to understand a few things about math and stuff like that, but it's actually very powerful, and I really think it's quite astounding what you've done. Well, we've actually got some more questions.
I can just add that
Garrett,
actually some people are. Just wanted to add that actually some people are doing it. I mean, they are using Castle Game Engine for visualization. I guess industrial visualization, what you would call it, like some machinery, and some other people for Windows we actually cooperate. So it's yeah, you
I
can use
met
it definitely not just for games. You can
when I
fish
went
out
to
some
the
questions. Actually, go on.
Yeah, sorry. When I went to the Delphi Summit, I met a guy there who had a mobile app, and he lived in a building, like a multi-floor building, but he put Raspberry Pis on each floor of the building, and it controlled things like the lights, I think some TV, security cameras, a few other things, like basically tricked out his house, and I think, I'm not sure, but I think he was using FireMonkey 3D to visualize this, and he had a problem where the light, what he did was, it was realistic. If you turned on a light, his little preview lit the light up, with an effect. But he had an issue with FireMonkey where I think if he turned one light on, then the other one didn't look properly, and that's why he was talking to me about it. It was a bug, but actually he could have used your app and done the same thing, I think, and visualized it probably more effectively as well, because the wireframes that you were loading in for the characters, I was busy answering emails and messages. Did you mention somewhere where you can get those wireframes for the characters, or did you not mention that part of it?
You mean the three-dimensional models? Yeah,
Yeah,
from
of the
Quaternius. They are
players.
from the they are from the Quaternius. I don't think I'm allowed to post links on YouTube, but it's
You
available.
can post it in the
If
chat,
you
and I
go
can
to
post it in the link. Yeah.
yeah, it's available also in this in the links, the example. So those are, I mean, there's a bunch of people actually doing great open source art, and this includes doing open source models. And this guy is called Quaternius. He's doing a public domain, three-dimensional models. So people like me who can write code, but I can't do graphics, we can just use their work. He created animated models of pirates. He has a lot of more stuff on his website available for free. You can also support him, actually also on Patreon. Go ahead and do it. And yeah,
definitely.
there's actually a lot of such websites. I mean, maybe not a lot, but a few, and they are really, I would say, really worthwhile. I mean, what I want to say, there are a number of people right now that actually like we're talking here about coding. Okay, I'm talking about coding because I know coding a bit. But there are
Yeah,
a lot of people on the like artistic side that are preparing the assets for your games, applications, 3D textures, whatever. There are a lot of passionate people about this, and they
yeah,
do give their stuff for free, and we love them. And
yeah,
there are a lot of more links to such sites. You can I posted to you another link. There are a lot of such sites, well, not a lot, but a few, a few that are worth it. And yeah, those people are great. I mean, we are like doing coding open source often, and they are doing art open source often, and that's a great cooperation.
yeah. It's funny because that does seem to be the case with games as well. Because I have a friend from long ago who actually used to work for Microsoft Rare Games, and I think they now work entirely for Microsoft. They worked on the Xbox and a few other things, and worked on Banjo Kazooie and all sorts of games like that. And he works on the game engine for Microsoft, but he couldn't draw to save his life, and he's definitely not got any graphical abilities whatsoever. And they of course have people whose only job it is to design all the assets, and I think that's very common in because I've worked in a few software houses that also did games as well. I never worked on games, but I did work on one product that was a designer, like a graphical designer program, and I worked on the code that did something else. But it was the same thing. They had someone whose job it was. They went, in fact, several people. They went away and designed the assets. We would then consume the assets in the app, and it makes us look good. It's just like I always say. All the clever people make me look good. I just present what I get, and off I go. Yeah, I see where you've got this link as well. So I'm going to copy this link, put it in the chat.
Yeah. We can ask actually. I think I noticed that two questions in the chat in the meantime. So
Sure.
about Nigel, I'm sorry if I mispronounced your name. So Nigel, you asked about what limits are there on the graphics quality, such as resolution, color depth. There's in the chat. So none. The answer is none. I mean, okay, there are limits. The limits depend on your GPU, but we don't impose any special limits. We just use OpenGL or OpenGL ES, the embedded version, depending on the device. And we just allow you to have any resolution you want to, and any resolution that OpenGL allows you to. We also allow you to actually change the screen resolution at runtime, even if that's like allowed by your system, like Windows. So there are no limits. And the color depth depends on what the OpenGL is giving us. By default, we ask for the 32-bit color buffer as normal, yeah. But again, we are not limited essentially by anything. You can tweak the parameters of how the context is created, and you can request anything. So we do work with kind of everything that your graphic card can handle. Yeah, so that would be the answer.
Yeah, and also when I was asking you about the question about the dancing thing, he said, "No, Ian, you got it wrong, and you got it right." So you understood what he meant about the animations. You gave the correct answer, and I misunderstood. He also
I gave a few answers. Yeah, for this one, the answer is also simple. Anti-aliasing, yes. There's a property called anti-aliasing on the container. Just set it to something larger than one, and it's called multi-sampling. Sorry, it's called multi-sampling because that's kind of a technical term for anti-aliasing. I mean, what happens is you render for each pixel you actually make a few probes and you average them, and that's how you do anti-aliasing. So yes, it's called multi-sampling. Set the property called multi-sampling to something larger than one, and draw it with my fingers. Set this property to something larger than one, and that's your anti-aliasing. It's available everywhere in Castle Window, in Castle Control, so also in the FireMonkey and VCL components. Yes.
See, this is why I say, like, games designers and things like that. You guys, you're on another planet when it comes to the math and the logic behind it. Because, oh yeah, you just probe a few pixels and you say that like it's really easy to do, and I can tell you, people watching, it is not easy to do. It's really not. That is something that the Castle game engine. That is why you use a game engine and don't try and do it yourself. It's a really tricky stuff, and Michalis makes it sound like it's easy. It's yeah, brilliant. And so let me just there was a couple of other questions as well. Oh, and Patrick, who writes his own games as well, he does some other stuff. He says, so it works like a viewport for a CG product or scene. Good. So I think he's understood what that. And some love for what you're saying as well. Very interesting webinar. Thanks, Michalis. Yeah, great stuff. Hey, Musa, if you really love it and you decide to use it, go to the Patreon. I mean, you know, Michalis is not getting paid to do this presentation. At least I don't think we have. No. But we obviously, you know, we support people like this in other ways. You know, tech partners and MVPs and things like that get a few benefits. And it's a collaborative thing. It's really for the greater good of the community. But, you know, Patreon goes directly to Michalis. It doesn't go via anybody else but that. So if you want to make sure that, you know, you show some love, the best way is show some financial love, and that helps. Although using the product and talking about it is good as well. Nigel also says, very interesting webinar. Thank you. It's great stuff. So, yeah, you're doing well. I think people seem to love it. It's funny because when we first started out, we had quite low live figures, and I'm messaging my colleagues and saying, did we promote this session properly? Did we put the wrong timer? But as we came along, the numbers steadily went up like that. And I know from experience that for the games engine, the webinars that you've done in the past, there is a lot of interest. And just kind of bit of a housekeeping comment here, that I know that the day-long replays are long. You're talking about 4 hours of content. All the sessions, including Michalis' session, will be split up into individual sessions. So if you want to watch this again, we will put it out probably next week by the time we get around to it. You'll see his session in a nice little chunk. You won't have to watch all the content around it and me talking. It will go there, including these links that down here as well. But we know that we get thousands of people watch the replays, particularly for your session. So, you know, it's great stuff. Okay. All right. Well, we're kind of running out of time. Was there anything else you wanted to cover whilst we were at it? I'm going to put the QR codes up while we're talking as well.
I think you covered everything. I guess I just wanted to say thank you. Thank you, everybody, for listening. Thank you, everybody, for the good words. Thank you for having me. Thank you very much.
Well, hey, Michalis, thank you as well for taking part. You know, it's people don't realize that these presentations, I say this every time, for every hour of content that someone sees recorded, there are many hours gone into getting that thing ready. I know that because I do a lot of webinars, and I know that, you know, if I do a 45-minute presentation, it's taking me a couple of hours minimum to get to that point. So I know how much work went into it, and I want to thank you for doing that. You know, hopefully you get some people signing up, but also, you know, generally, I know you do it for the community as well. So thanks a lot. Okay. All right. Well, thanks a lot from Michalis. We're now going to do a couple of things in our little chat. People always say, "Oh, thank you" in the chat. We have like a little private chat down here with producer Martha and myself, and I never have time to say thank you. But thanks, Michalis. Yeah, there you go. See, he's already said thank you in the private chat. Thank you as well. Right. So Louis says, "Oh, you should be able to enable anti-aliasing on the samples." Well, there's a Louis. That's a little bit of a challenge for you, isn't it? You go ahead and try that. But you can download it. We put the links up, and we will put them up again later. We're going to start looking at what we've got rest of the day, because we have many things coming up. What have we got? Okay, so the next session, which is in about 2 or 3 minutes, is from Juan Castillo, who is he was here the other day about logging, and this session coming up is about advanced logging. So if you, and in fact, games are the kind of thing that would log, debugging information, but usually web apps and server apps. If you write a Windows service, for example, so it's not visible, it doesn't usually have a user interface. In fact, it almost certainly has no user interface because they're designed to just run in the background and do things. You want to log things. You can either log them to the event log, the Windows event log, if it's a Windows app, or log it to a file and a log file. That works fine, except when you've got an app that's got lots of multiple threads coming together, and you can get a thing called a deadlock, where two threads try and do something at the same time, and if you haven't written the app correctly, they lock each other up. Quan's library, its logging library, has got multi-threading capabilities and also filtering for there. It also is going to discuss about performance enhancements and tweaks that you can put in to make sure that your logging is performant. After that, an hour after that, so an hour and a bit from now, we then have a live session from Miguel Angel Moreno and Marino, and it is resource allocation is initialization for Delphi. It's a bit of a mouthful, but RAII. So it's about when you allocate a resource and how the whole thing hangs together. More advanced topic, but it is live and it will be using Delphi. His session yesterday, which was also live, was using C++. He's a multilingual developer, or polyglot as the other phrase is, but he's a great live presenter, and got a lot of time for Miguel, but he'll be on later. Anyway, let's get to the hour and let's kick off the next session, which is from Juan Castillo. And I'm going to put the caption up because I know that producer Martha set me up with some links so that I can look a bit better. This is the upcoming session then. It's about 50 minutes long, and then I think Juan is going to be around for a Q&A afterwards. See you soon. Bye-bye.
Hello, everyone. Welcome to this session of the Dev Days of Summer 2024 edition. Today we will speak about logs from an intermediate to an advanced level. We will check some of the nice features of the JackLog library. My name is Juan Castillo. I am a developer, consultant, and Embarcadero MVP. I am based in Guatemala, but today I am speaking from San Jose, Costa Rica. So, pura vida. This is today's agenda. We will check what is a log file, the platforms that the library supports. We learn how to log stack traces in case of errors. We will speak also about some of the architecture of the library, covering topics like log writers and log destinations, the topics of the log, the filtering of the logs, and finally we will speak about performance. So let's start talking about what is a log file. I want to start saying that historically, a log file is an official record of events during the voyage of a ship or an aircraft. In computing, log files are historical records of everything and anything that happens within a system, including events such as transactions, errors, and instructions. That data can be stored and transmitted in different ways. A log record is the information related to an event that took place in a certain time and might have metadata that contextualizes it. Jacklog is a library that allows you to add text logging capabilities to your application in minutes. I also want to say that logs are an industry standard and there are a great ecosystem around them, and that gives you a lot of tooling to process and extract a lot of valuable information from them, not just the very detailed trail of what happened during runtime, but logs are the foundation of the observability and monitoring of many, many applications, both client, but especially server side. So, what is supported by the library? Uh, I want to say that Jacklog is a lightweight yet powerful library that allows you to write text logs from any Delphi application from desktop, where it supports VCL and FMX applications, and console and all kind of server applications. Writing logs is also possible from a dynamic link library. Speaking about operating systems, being a pure Pascal library, all what Delphi supports is it's supported by the library. Currently, it means Windows, Linux, Mac OS, and Android. And in the future, if the product supports more operating systems, uh, I, I, the library will also support it. So let's check the first topic of the day, and that is how you uh, record the stack trace in case of errors. And one of the nice things that you may want to keep logged in case of any error is not just when and the error happened, but you need also to know where it arises in your code along with some additional info. In my experience, this is one of the most powerful tools a developer can have to catch errors that are difficult to reproduce. Sometimes it only happens during runtime in production or in a customer computer or device. So to achieve that, the first thing you need is to get the exception object to carry information on what was the state of the stack, the call stack, I mean, when the error occurred. Then you need to translate this information to the actual names of the entries in that stack. Currently, the library supports using the JCL debug unit for that. This unit is part of the Jedi library, which is also open source. And to allow this to get logged, let's go to the IDE. And like the Jacklog library, the first thing that you need to do is to install that library in your IDE. We will also use the Get Package Manager to do that. So I will search for the library directly with its name, and I will just install it. While this installs, the next step is to include the debug library info in your exe application, so the library gets the capability to translate the stack into the Pascal name of the entries. To do that, you need access to the debug information on runtime. So usually you have this at hand on the debug version of your compilations. But if you want to have it in the release, you can also add that information. This makes your exe grow a bit or a significant amount, but this gives you the traceability inside your exe to know where the errors are arising. And the next step is to define a symbol that makes the library to do that process. So let's wait this to get installed. And if you haven't seen my previous presentation on this same developer days, uh, please visit that because I will use the same applications that I added the log in the first session to continue uh, using them in this presentation. Okay, everything is ready. So we have to start the ID. So I will reopen the CRM demo. Okay, so now I will go to project options. So I will define a new symbol. It has to be named as exception stack trace. I will save. And I will just hit run to see what happens in the log. So if you remember from our first session, I will just uh, manually raising an exception when we change to the marketing page of the page control, the main page control. So I will go there just to make the exception happen, and I will, in the meantime, I will open the log file for this application. So we are looking at the log in real time. I will go to a page. The log reflects the change. And now I will visit the marketing page. The error message appears and the error gets logged. But if you notice, there is a change in the log file. And if we take a look at the what was written to the log, we have the error severity. This is the message that we uh, writing to the log that we write when calling the log method. This is the class of the exception. This here. This is the message of the exception, and there is the different thing that we are doing now. So here we have the stack trace, and this stack trace reveals where in the code the error happened. The error happened in this line of the system sysutils.pass unit. But we can also see from what other points this. Sorry, we have also the function or method name that was executing at that time. In this case, it was inside system sysutils string to integer function, and this was invoked from the same function, and this was invoked from the tab sheet do show, and we can look here where the execution was going. I mean the complete function and method call. So we can reconstruct the execution path that led us to this error. And as I said previously, you can have this in a release uh, application, also not just in a debug application. So to have it in release, you have to include the debug information. I mean the debug symbols along the exe, and that's everything. So now let's speak a little bit about the architecture of the library. Uh, the library, I mean the logging object is inside we have different abstractions. One abstraction is the main log engine. This is the object that we instantiate in our code, and the object that exposes the method that we call to write entries to the log. And this engine just receives the logs, but the actual writing of the records to the different destinations are done in different objects. And these objects are created and registered at runtime, and the library out of the box supports writing to disk, I mean a plain text file, to syslog, being the syslog remote or local, to a database, for example. We can also write the log output to the user interface, as we shown in my previous presentation. And there are more destinations available, and I will be adding more and more as the library grows. The features of this approach is, of course, that if you are not interested in writing log to a specific destination, let's say a remote syslog server or to a database or to disk, for example, you simply don't create the an instance of that class of writer, or if you already have one instance created, you just unregister and destroy the writer from the engine, and doing so, the engine will be not wasting any time uh, processing entries to a destination that is not part of the actual writing of the messages. This is important because, of course, processing the messages and the actual writing of the messages to different destinations takes time and has costs involved in time of processing and memory use and other resources. So if you are not going to write to some destination, you just don't instantiate that writer. The other nice part is that for the already created writers for different destinations, you can activate or inactivate the writers depending on your runtime conditions. So you can stop writing to an already created destination. That's a nice thing. On the other hand, you can also write your own writer classes to reach a particular destination if that's not supported out of the box by the library. So you can write to new destinations or write to existing destinations, but on a non-standard or ad hoc way. A typical case for this is to write logs to a database because you might have a particular table designed for to store this log, or you might be working with different database vendors. So it's up to you to write the final class. You have a class you can inherit from to just write the specialized part to consume your model. And I am planning to add to the library classes to write to some popular databases in a standardized format like SQL Server, MySQL, Oracle. But uh, the dependencies here tend to be complex. So I am planning to support FireDAC out of the box because this is the standard library to connect to databases, but there are lots and lots of other libraries. So you can use anyone, any library that you want. So what you do is to create different topics. A topic is an integer number, in fact, a byte uh, type of number that is the index of the topic you want to mark your entry with. And you can create topics like database or transaction or network or security or whatever it's proper for your application. So this will allow you to rapidly identify the subsystem, for example, that originates a record when inspecting the log, but this will also allow you to manage different filtering levels for different topics. So you might be tracking a particular failure or behavior in a particular subsystem, and you can, for example, allow debug records on that particular topic, but on other topics, you maintain the filter to higher severity levels, or you can even turn off the output of the log for the topics that you are not interested in a particular moment. As I said before, the topic it's a byte-sized integer that is the index of the topic. So you can have up to 256 topics, which up to now it allowed a lot of room for very complex applications. If you need more topics, write a feature request on the GitHub page, and let's take a look on what is your use case and how can uh, we support more topics. So now I will get back to Delphi, and I will add some topics. To do that, I will create a new unit just to have these declarations isolated from other code and accessible on all the application. So let's call this unit the constant unit. Okay, here we go. And I will create three constants to identify the index of the topics. I will prefix this as log t, the log topic, and I will create one for database, which will be number one. Other one for userland. I mean, this will record what happens on the user interface. And the last one will be, for example, a networking topic that, of course, this application doesn't need, but it's just let you see what 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 can you do. So now I will change the uh, calls to the logging methods to add the topic. So all the methods support the topic as the first parameter, and you can configure the library if you want that your team always include a topic. So the methods that doesn't require a topic doesn't appear in the code. So let's include the new unit in the uses clause, the constants unit, and get back to the place where the first call is, and I will add the topic index to the call. And everything that happens at this level, I will classify it as userland. So let's copy the topic and just we will just visit all the calls and add the topic as the first parameter to the method call. Now I will visit the data model as we added a log record for when the lead changes the status, which is also a user action on this application. So I will also classify this call as a userland record. But for example, just to make the example clear, I will add the unit. So it recognizes the constants for the topics. And now I will add a event handler on this table, which is the table that holds the lead records on the database. And I will add a handle, for example, for the on error event, which is here. And if something goes wrong while writing to the database, I will just keep the that information on the log. Oh, I think the LSP server is not working. I'm sorry, my memory is just not good enough. I will compile to check if I have errors. I don't. So I will add this record here. And of course I will include the exception object. So everything that this object carries, I mean the messages and the class and the stack trace, get recorded on the log. So it compiles. But I will not only do that, but I will go for example, on the main form to do some configuration of the logging object. This is not the place that I recommend to do this, of course, but I will doing it here to keep this presentation and this demo sim very simple. So I will go to the form create method. I mean the handler for this event. And let's add before the message or the record that goes to the log. I will the LSP server is really not working. Give me a second and I will restart the server. Something went wrong. I don't know what happened, but this restart the server. So we get the code inside working again. Okay, here we go. I will first put this property to true, so the topic name gets recorded to the log, and I will assign the names for the topics that I will be using. You have to do this once at the first opportunity in your log object, so everything gets written correctly to the record, even the earlier messages. I will have no time here, but something that I want to mention is that you can, of course, get rid of the jacklog auto unit and write you the code. You can use the unit as a template, for example, but you can write the code that creates the writers and configure do the proper configuration for your particular needs. This includes the for example, if you are supporting the disk log, you might change the folder where the log gets written, for example, or you can do a lot of customization there. So let's run this. And I will show you the log, and you can see how now the records on the log includes the name of the topic that that record belongs to. So you can rapidly identify the subsystems or whatever that it means to your application that is producing this particular record to the log. Okay, so now we will discuss the filtering capabilities of the library, uh, kind of advanced filtering capabilities, and the filtering is done in 2 dimensions that are applied all the time to this engine or the engine are applying. The first dimension is the severity, and give me a second. I mean, the severity level. We will visit the page again for that explains the severity levels. But as I am saying, the severity level uh, go from the less severe level, that is the bug, to the most severe level, that is emergency. And when you are filtering records on this dimension, what you establish is what we call the log level. So if you start filtering, for example, on a particular level, what gets written to the log is every message that has that level or one of the higher levels of severity. And on the other hand, uh, all the records that have a less severe level, those records are ignored and never written to the log destination. So I will visit again this is the page for the library in GitHub, which actually hosts the code. This is the README of the library, and we will go to the wiki that holds the documentation for this library. I try to keep this documentation up to date, but if you notice something that is not up to date, let me know. And here are the severity levels. As I said in my last presentation, these severity levels are inspired in the syslog uh, severity levels. And as I was explaining, the level filtering goes from down to up of this list. So imagine you have a server that accepts uh, new customer orders for a website, and every request that is processed on the server requires an operative database connection in order to save the new order or make changes or delete an existing one. If the database connection doesn't work, the system usually writes a record with the critical severity to the log. That this is the less severity that you can use for an event like that. You can you maybe want to call this an emergency, so you write an emergency record. And if you establish your log level to warning, you can be sure that everything up from warning up to emergency gets actually written to the log. But the other messages, I mean the bug informational and notice, that never gets to the final destination of the messages. So the intention of this is that taking this in account, uh, you maintain, I think, a cleaner and cleaner code. The code is plain because you are not evaluating conditions on your code to decide what gets to a log. You just call the logging methods, and this is the library, the one that actually do the apply the logic to decide what goes to the log and what not. And the library is performant enough to allow this to not disrupt the operation of your software. So to apply the filtering, you use the log level property and you apply the filter levels to the other dimensions, which is the other dimension is the topic. So you can have different log levels to different topics. This gives you nice flexibility. So you can, for example, decide to log everything for the database topic in a particular moment, but for other topics, you might want to log less information or even uh, switch off this complete topic, so nothing gets written to the destination of the log for this particular topic. So this is very useful on different environments, from development to testing to production, because you may allow your users to change the level of filtering of your application for the log, or you maybe read this from an ini file or the registry or a database, or you can even make some programming to, depending on the conditions of the runtime, you can decide to change the filtering level of the different topics that your application supports to fine tune the amount of log that your application produces, because the log tends to be tons and tons of log. If you write everything, that's the idea, that your application is capable of explaining everything that is going on the inside. But for production, for example, you usually want to keep only the things that means that there is something wrong going on with your application, which is usually from warnings up to emergency, for example. And you can apply these filters on the global level, uh, which is what I did in the code, but you can also have different filters on the different writers. So when a record is sent to the library first apply the global filter, and the records that pass this global filter goes to the different writers, and then each writer apply the filtering level that have the writer. So sometimes you might want to use this by writer configuration, and at the global filter you let pass everything, and on this allows you, for example, to write different level of logs to a different destinations. For example, you might write only errors or warnings or up to emergency to a database or to a syslog, while you maintain a more complete history on text files that usually have the most capacity to process the amount of log that your application might be producing at any any particular time. As I mentioned it earlier, the log tends to produce a lot of information. So uh, taking this uh, library, you can find very fine tune your application, so that it allows you to do a complete tracking even in production of some problem that maybe is happening only on particular times, but on the rest of the time you only see the warnings and errors and emergencies and critical records on the actual log files. Okay, finally, and the time is running up. I want to speak a little about performance. I want to start uh, saying that the library has been designed and tested for performance. But talking about this, uh, you have one decision to make, and the this is that if you want an ever up-to-date log, you don't have but to wait until the log gets processed on every call that you do to a log method. By processed, I mean until the record gets written to all the enabled destinations, the filters applied and everything. So this creates contention on multi-threaded applications or even in single thread applications because the actual writing to the destination usually implies opening or closing a log channel. For example, to write to a disk, you have to open the file, append just one line or a bunch of lines that represent the record to the file and close the file. And you have to do this to make sure that the content is actually writing to the disk and on one hand, and on the other hand, that you keep that file accessible to other applications that may be monitoring or processing the logs on a way, even for display on the screen. So if you want a performant application, of course you might don't want to do what I said. And with jacklog, you can do the logging method to return almost immediately the control to your program so you can continue processing your transactions or whatever you are doing on a performant way. And the library maintains a series of queues internally. So the engine takes the record that you want to produce, uh, put it on a queue, returns the control to your applications, and on secondary threads, this record gets filtered and distributed to the different writers that are on runtime. And each of these writers on a different secondary thread processes the records, group the records that are available at a particular time, and for example, write maybe thousands of lines to a log file at once, which is also adds performance to the application. But of course, if your application, for example, have a crash, a critical crash, maybe the log will not show you the complete history. And okay, the time is up. I want to speak a lot more about this, but for now, I get back to Ian, and we will be answering your questions. Thank you for coming. Bye bye.
And Juan is joining us in the studio. His camera's turned off at the moment. I'm hoping he's going to turn it on, but we shall see. Are you there, Juan?
Hello.
Hi. Your camera's not showing at the moment, so that's fine. Maybe you don't want to be on camera.
It failed. Yeah. Hey, how are you?
I'm good. How are you?
Yeah, fine. Thank you.
Yeah, we were both talking in the background about flying around on aircraft because it's always horrific having to wait at airports.
Yeah, sure.
Yeah, I think every time I talk to you, you're in a different country.
Yeah. I like to travel, but I don't like the airport time and.
No, me neither. It's all right once you get there, then it's cool. But then you've got to get the flight and security, and it's horrible. Anyway, It's great stuff. So I've got a couple of questions then, sort of lined them up for you. First one will be, what made you decide to write Jacklog? And is that, am I pronouncing it right? Jacklog?
Yeah, it's what I think is the best pronunciation in English.
Right. Okay, good. Yeah. So what made you decide to write it in the first place?
Yeah, you know that I really started a lot of time ago, and at the time I didn't know any other library that does what I wanted to do in logging, and I really started this on one of my projects of the time. But from that moment, I keep maintaining it, and it got integrated in different software. So I started to rethink and made some change to the architecture, and the library I thought was mature enough. So I decided to uh, extract it from I mean to make this a library, independent library, and to make it open source, so maybe others can um, just use it because it works. But it was a long time ago that I decided to write it, and it was because of I know no other library that can do what I wanted at the time.
Yeah, I mean that was the thing that we were talking about behind the scenes is what makes it different. Well, I think the answer you would probably give is that try it out and see.
Yeah, yeah,
Yeah,
sure,
you
sure.
know,
I think it works for me, and I know other people that are using it, and it works for them too. So I think if you are not already doing or using another library, it you need to try it and make your own decision
yeah.
about it.
What? Just remind me, what sort of outputs can it write to? I know it can write to a file. Can it write to other things as well? What were the other devices?
Yeah, out of the box, you get the file writer, you get the UI writers, one for VCL that supports the making the output with different colors and everything because it uses rich edit to make the output. On FMX we use a memo, but we have both flavors, so you can put the output to the user if your program is UI. You also get syslog. The syslog can be local or remote. This is based on INI.
Oh, really? That's
Yeah,
interesting.
yeah,
Yeah,
sure.
interesting. I didn't know you could do remote syslogging with that library. That's actually
Yeah,
something that other log libraries they can't always do that. The local one is not too bad, but a remote syslog is very interesting.
yeah,
Um,
yeah. And that way you can consolidate the logs. For example, if you have uh, a server farm and you are running different instances of a software, you can consolidate the logs using syslog. So that's very nice. And I have now base class for doing log to a database, but you have to write the specific writer. I mean, inherit from that class to use a particular database vendor and your table design. I am planning maybe to add a standard table design and support some databases through FireDuck in the next version, but I am planning it now. But uh, in some months, I think maybe you can use that out of the box also to write to a database.
yeah,
And
I mean that will be quite popular, I think. Excuse me,
yeah,
because I think for some
go-
people, if they're writing Windows services that are communicating with databases, if they've got a connection to the database, then it makes sense to log to the database, and they've got everything in one area.
Yeah, sure, sure. I have a customer that logs everything to a database. I don't like that much the idea because the database is for other things. I know, but I think, but they are doing some monitoring based on the database, and the previous version of the software already was doing that. So they have this tooling also in place. So they didn't want to change the everything. So we are writing the log to the database in that case.
Yeah.
And I am evaluating another use case, and that is to use a queue to write the log, so you don't lose the log if something bad happens to the server.
Yeah. So it queues it up. That's a good idea as well. I mean, I agree with you. I think logging to databases is okay, but it's error prone because you're relying on the database. I mean, even a
Yeah,
local
and it is
database.
slow. Yeah,
Yeah, exactly. Whereas output to a file, because you showed in your demos that you can do multi-threading
yeah,
logging as
sure.
well, and not all databases handle that particularly well. Weirdly enough, you would think they would be the opposite. And also, you say it's open source. It's open source and free, right? That's correct.
Yeah, sure. The license is the MIT license, if I remember correctly. But I put put some attentions to decide what license to use, so you can use it freely and in commercial projects with no problem.
That's excellent. Yeah, well, if people want it, there's the QR code. But as Patrick says down the bottom, because Patrick is our little man who does everything behind the scenes, us he's supposed to be working and doing something else. You
Yeah.
can also get it from GitHub there, and it's on Get It as well. So if people just go into the IDE and go to Get It, they can get your log from there. But it's great stuff. Thanks for the session. I really appreciate it. That's 2 sessions you did. One after another, and they're both quite long as well. So I really appreciate the effort you put in. And you were worried about your accent. Now you said, "Oh, I hope people understand me." I always say this to you. Your accent is absolutely perfectly fine, and take it from someone
Okay,
who's
thank you. Yeah.
English. But it's great. But you said you need to speak more with people speaking English. I think to practice. I think that.
Yeah,
It's the same.
my spoken English is rust because I never speak it. I very rarely speak English, but
Yeah, it's the
I have
same
to
with me in
practice.
French. Years ago, I used to look after a French grandmother, and at the time, not my grandmother, someone else's grandmother, and at the time, I could speak French quite well. But
Yeah, sure.
now, many years later, I just don't get enough practice, and that's an invitation for Patrick there. But I don't get enough practice, and then I feel like a little child because I'm like, oh, what was the word for
Yeah,
something?
yeah,
You just
it
completely
happens.
forget, but you can speak fluently in your own language, of course, and it's frustrating. But anyway, great stuff. I appreciate you taking the time out to present to people, and I'm
Thank you
sure
for
we'll
having
bump
me.
into each other
Yeah,
at
yeah.
another event around the world and online. But for now, thanks a lot, Juan, and take care.
Thanks to you, Ian. Thank you for
No,
having me, and goodbye to everyone.
yeah, thank you. Bye bye. So that was Juan Castillo. Our other guest is around, luckily, because I saw him disappear. I thought, oh, is he still behind the scenes? But no, he is around, luckily. That was Juan Castillo. The next session is live because he's much braver than me at doing live sessions. And that is also from the Southern Americas, I suppose is the best way of describing it. And that is Miguel Angel Moreno. I hope I'm pronouncing your name properly, Miguel, because you always say it and then I'm too busy typing things in it. And he did a session yesterday on C++. And just to prove what a great developer is, today he's going to do a session in Delphi. And the session is, and let me just pull the little link up because I have got it already here. This one, which is resource allocation is initialization for Delphi. You can turn your camera on, Miguel, because at the moment your camera is not turned on. There you go. See, he's arrived. How are you doing?
I'm fine. Only this thing seems to be frozen. I don't know why.
Oh,
Anyhow,
okay.
I'm here.
Well, as long as your screen works, that's the main thing.
Yeah, no worries. So yes, well, I'm here. The topics that I've been presenting are related. The one I presented yesterday was related to C++ by doing that something that C++ doesn't have, at least not natively, which is the tri-finary blocks. Then again, it's still impressive that from the top 10, 20 languages in use today, C++ stands as the only one that doesn't have tri-finally. And it's because Mr. Bjorn Strostrup said no need. But anyhow, there's use cases, as I showed yesterday, for tri-finally. Now, I'm going to go the opposite way. C++ relies on array completely. That's why they say no need tri-finally. But there are some use cases that might be good in Delphi. So that's what I'm going to show today. What are those use cases and how to implement them?
Excellent. Okay, well, I'll hand over to you then, and we'll speak a little bit later.
All right, sure. Thank you, everybody. Welcome. My name is Miguel Ángel Moreno. I'm going to present resource allocation is initialization, RAII for Delphi. So first, who I am, I'm an electronics engineer by trade. I'm an IoT systems designer and architect, and then also software developer and systems integrator. And I've been Embarcadero MVP for more than 10 years now. This is the agenda for my presentation. I want to show you the history of the try except and try finally code blocks.
Sorry, Miguel, we can't actually see your screen at the moment. You need to share your screen.
Oh, sure.
We can see your camera, but if you...
I see, yeah. Yes, you're right. Then let me just, hold on. Let me just reset this whole thing quickly. Hopefully you notice quickly without me going 20 slides. Okay. All right, so share screen. All right. Should be sharing now. Can you see it? All right. Sorry about that. Let's start again. So I'm going to present resource allocation is initialization, RAII for Delphi. I'm Miguel Moreno, electronics engineer. As I said, system designer and architect, software developer and systems integrator, and Embarcadero MVP for 10 years now, more than 10 years now. This is the agenda for my presentation today. I'm going to show you the history of try except and try finally, where do they come from, why we have them, comparison of those two code structures, try except versus try finally, and then what is resource acquisition is initialization, what's that? Then introducing an explanation of the lifetime of records in Delphi. There's been some big evolution on those that you need to be aware of, because thanks to that evolution applied to the compiler since 10.4, now we're in the position to compete with C++ and have some RAII in Delphi with custom managed records. And I'm going to show you some examples of RAII applicability by use case. And finally, some example of a real life Delphi project with RAII. Finally, but not least, the questions and answers. All right, first, history. Try except and try finally together form the set of programming mechanisms and flow control structures used for exception handling. Now, many think that exception handling was introduced by C++. That's not true. Lisp, the programming language Lisp, introduced the first generic exception handling in the early 60s. Only it was a very generic trapping mechanism. You could trap any kind of error, store it in a structure called error, and then with a function called error set, you could check. The advance here is that instead of having a program terminating and immediately going to the command line and just dumping out an error, is if you use the combination of these two keywords, you would actually able to catch the error, and then you would call error set separately, and then you would nicely handle it. So this was the very first time that the developers could catch an error rather than the program terminating directly to the command line. Later on, MacLisp introduced specific keywords since the designers noticed that that feature of the error and error set were being used very wisely by programmers to do real logical catching of errors to alter the process flow. Then they decided that they needed to separate them. Then they dedicated the new keywords, throw catch, where you would throw an error and catch an error, but these would be logical errors, not hard errors. Then this is the first time we have these words, which actually stay nowadays in C++, but this was introduced in 1972. And then the new implementation of Lisp, called NIL, introduced the first cleanup behavior that today we know as finally. So they didn't call it finally. They introduced this keyword called unwind protect, which do the same thing. If you define this code block under this keyword, you were allowed to do some cleanup code before raising the exception. So this was the very first logical implementation of a try finally, although they didn't call it try finally, they call it unwind protect. In Delphi was introduced in 1995 as an evolution of Turbo Pascal. Turbo Pascal didn't have any try finally or try except, but Delphi did. Since version 1, that was one of the big improvements on the Object Pascal language, which was intentionally targeted to be introduced once the evolution from the stepping up from Turbo Pascal into Delphi. So Delphi has had these concepts since the beginning of times. Now, this is a quick comparison, just a reminder of what can you achieve with these two code structures. Try except in a normal flow will come from a normal external code going to your try code block, and if there's no exception, no error happens whatsoever, then it will simply jump over the except code, the except portion of the code, and continue with your external code. That will be the normal flow when no exception happens inside your try code block. But when there is an exception, the whole idea is if that exception happened inside your try code block, the exception will be, from the moment the exception is detected, can be in any point within your code block of try. Can be at the beginning, and the middle, at the end, doesn't matter. As long as it is within your try code block, if an exception is thrown or raised, then the compiler will jump directly to the except code block, where you have a chance to handle the error. You can either totally handle it completely and continue the normal process flow, or you could do some temporary handling processing and raise the error again to allow a higher level handler to handle the error. You have that option. But the point here is that the compiler is creating all these low-level coding execution so that you can have a chance to handle the error in case it happens. Now, try finally, which is a sibling, and they are like a brother and sisters in this scenario. Try finally will always execute the try portion first, and then finally will be just sequentially executed right after the try block. So in a normal flow, finally is always executed, unlike the except block in try except, where except is only executed in case of an exception. In a try finally, the finally block is always executed. Why do we have it then? Why do we need it for? Well, when there is an exception, the difference here is that finally gets a chance to run some cleanup code. Now, this is not handling the exception. This is the difference between these two. The concepts are very similar, but finally is not handling the error. It's just doing an interim step to allow you to do some cleanup or some finalization code that needs to be done before you continue raising the error to an external handler. So in this case, the first part, the try code block behaves exactly the same. You define your try code block where you execute your code, and in case an exception is raised, the compiler will jump immediately to finally. But now, finally, in this case, is just allowing you that this code will always be executed. You can see here clearly that regardless there's an exception or not, finally code block is always executed. But now, why ArrayII? Well, this is a concept defined by C++. As I was explaining in the briefing before starting this presentation, C++ notably is the only one of the top 20 most used languages today that doesn't have try finally. So notably, they were one of the first ones after Lisp to introduce try catch, which in Delphi we call try except. So they introduced exception handlers from the very beginning. The plain vanilla C does not have exceptions handlers, doesn't have try except or try catch. C++ does. From the very beginning of the conception of C++, they introduced an exception handler. But in the decision making done with the creator, Jan Strostrup and his team, they decided that try finally was not a good idea. And instead, they introduced this concept called resource acquisition is initialization. So this is an idiom or code styling that is being enforced for all C++ coders and programmers since the beginning of time, since C++ was introduced. So this is the way they say, if you want to do something that logically looks like a try finally, use ArrayII. That's the solution that is being promoted and enforced in C++. But you would say, what's the concept? Why they decided to do that? How does that apply if I wanted to do that in Delphi? Does it even make sense? Well, I'm repeating here again what you would have in a normal try finally in Delphi. On the left-hand side, you have your try code block, where if everything goes normally, you would simply step directly into the final code. But we're treating the exceptional case here. When there's an exception, the code in your try portion stops executing, but it jumps immediately to the finally code block. So then again, you have a chance to run some cleanup or finalization code in the finally code block. That's what we are used to do in Delphi. Then we just try finally when you need to deallocate some objects that you created on the heap, or close properly a database, or close a file, whatever resource that you need to clean up before continuing handling the exception and passing it over to another handler at a higher level. Now, to achieve the same logical thing in C++, this is what they tell us to do. So you create an object, which they will call the ArrayII object, and then the initialization code is done in the constructor of the object. And any finalization or cleanup code or the allocation, whatever, that you would normally conceptually have in a finally code block, you put it in the destructor of this specially created object for this single purpose. Then you just, all of this is encapsulated in either on a function or in a code block. You can have an indentation to create an indented or nested code block. Why? Because that way, you can see here the block in yellow represents the code block that implicitly provides the lifetime of the object that you're creating. So the idea is that you create the ArrayII object at the beginning of this block, either a function or a nested block. You create that object. By creating the object, the constructor will run and it will do any initialization, which that's why resource acquisition is initialization. At the moment the object is being constructed, you acquire any resource that you need to lock in this case or acquire. Then after the object has been created, in the rest of the yellow block, you have your normal code executing, your standard code. And in case an exception is raised, because in C++, when you are out of scope, the object gets destroyed automatically, then this is deterministic that if for some reason an exception is raised inside your function or inside this nested code block, The compiler will do a cleanup of the object first, the array II object. And because it's doing the cleanup of the object, it means it will call the destructor. And then implicitly, when it calls the destructor, you had already put your cleanup code in the destructor of the object. So it's like an implicit or forced way to put your logic of finalization in the destructor of an object that will be cleaned up the moment that an exception is raised. It looks weird to explain, but actually in code, it looks very clean. But you need to understand what's happening, and that's the reason I'm trying to put it here. For seasoned Delphi developers, it might look like a crazy idea. Actually, there's been a lot of discussion in many forums. For standard Java developers and Delphi developers and other, even in .NET, C# has finally blocks. So there's a discussion in forums that the way C++ forces you to do a finally treatment of code is a bit crazy, because they are the only ones forcing you to do this array II thing. But nevertheless, there are some use cases that it comes handy, even in Delphi. So bear with me, and I'll show you some cases. So array II is excellent for allocating and deallocating resources needed only within the scope of a given function or code block. Yes, this is one thing you need to keep in mind. This is perfect when you are allocating something that is the scope of where you need it is very well defined. Is used only inside a given function, or is used inside a specific nested code block. It doesn't make sense if you're talking about an object that is used through the whole lifetime of an application running, where you have like a BCL application or a FileMonkey application. You're thinking of having the object created in the constructor of the main program and then deallocated in. That it doesn't make sense, because the lifetime of the object is very messy to follow up. It's very messy. It doesn't really make sense. It only makes sense when you have a specific, simple to manage code of block where the lifetime of the object is deterministic. So that's why it's very specific to simple, small code blocks, namely, mostly is within a function. It's also called scope-based resource management because of this nature of what I'm explaining. It's defined by the scope of the code where you are introducing this object, the array II object. Then it's good for managing the resources within the scope of that code. One of these main uses is also in declaring inline variables and auto variables in C++. Because of this, it works only for resources acquired and released either directly or indirectly by stack allocated objects. Here is a catch. This static object lifetime is very well defined. The problem is that Delphi objects are always heap allocated. They are never stack allocated. Just keep in mind that in Delphi, normal variables, local variables in your functions or procedures, they are stack allocated. So what this phrase means is that in C++, you can have objects that behave like the local variables. They are allocated on the stack, and then the lifetime is temporary only while the function is being executed. That's why array II works very well in C++. But Delphi objects are not stack allocated. You need to manually create them, and they will always be in the heap. Before some of the most seasoned programmers complain out there, I made the disclaimer at the bottom. The good old Turbo Pascal did have stack allocated objects, but those has been deprecated, and no one at Embarcadero is recommending you to use them up because their legacy code is not even maintained anymore. So just to clarify, but modern Delphi objects are always heap allocated, never stack allocated. So that is the main reason why, even though Delphi is been around together with C++, and even its closest brother is Turbo C++, which now evolved into C++ Builder, even though they have array II, it was never tried to be done in Delphi because we can't. The features of the compiler for managing objects are different. Another thing is ArrayII is not useful for finalization or cleanup code that is not related to resource deallocation. In other words, let's say you want to run a code that does some cleanup on a database or code that does some special sending messages or whatever, that is totally not related to an allocation that you did inside an object. So for those purposes in Delphi, just go and use try finally the way you've done all the time. Don't go bother with ArrayII. But yeah, some of you will say, yes, there are some ArrayII implementations in Delphi, but those traditionally have relied on using interfaces and reference counting. It becomes a bit messy because you need to define interfaces first, and then you need to define an object that implements that interface, and then you rely on the reference counting behavior of interfaces. It works, yes, and there's a lot of frameworks out there, notably FireMonkey, that uses interfaces heavily, and part of it relies on this reference counting. But I would say if you're truly requiring interfaces as part of your design, and as a side effect, you want to use ArrayII, okay, fine, because you're already relying on interfaces like for code injection or dependency injection, then that's fine. But if you want to just have a simple ArrayII inside a simple function, the way they do it in C++, the way traditionally you would do it in Delphi is too much by doing these interfaces. Until now, because now let me show you what has happened with the lifetime of records in Delphi. So the first thing I need to show to you, hold on, in here. I have a simple code here showing you how the standard records in Delphi behave and have behaved since the beginning of time. So I'm defining a record type here. It has 3 fields, a string field, an integer, and another integer. The integer called ID is one that I'm doing internally to assign a sequential ID every time a new record is assigned. So I'm just keeping some internal sequence generator, which is controlled by this global variable. Let me just compile this quickly for you here and execute it. What I'm doing in this program is defining the standard way on a header variable, header declare variable in Delphi, which is variable A, which is an instance of my record. Then once the program starts, I call the constructor of the record to initialize its internal fields. So I'm assigning a name and a value. Then I will show the values. Then I'm creating another variable B, and then a variable C, and then variable D. All of these are instances of my record, but created at different points. And also I'm created another one inside a local function, a local procedure, the procedure called do something, then I'm creating another one. So I'm created different variables of the same my record type. Let's see what happens when we run this code. Here, here. I have added in the constructor of the record these helper functions to tell us what's going on. And I'm printing every time their constructor of the record is called, just printing out that the constructor has been called with some given parameters, and then the sequential ID of this. The sequential ID will only tell us how many times the constructor has been called for different variables. And then I have a normal method defined for the record when I'm just printing out the values. Delphi, since the beginning of time, has had smart records that allow you to add constructors, just like as if they were objects, and also allows you to add methods, again, just like if they were objects. But the key difference is that records don't have inheritance, so they also are not polymorphic. So all the nice things that you can do with classes, records, the only thing you can do is add methods and constructors to make it easy and simple to manage the way you create them. It would be similar to a class creation. But other than that, records don't have all the nitty-gritty features of true inheritance and polymorphism of the Delphi classes. So that's been the barrier. They behave like normal records. They're always assigned on the stack. You could also dynamically create them with a new operator. So what I'm catching here is just showing you every time I call this convenience constructor, when I'm assigning the internal values, and also calling this, dumping these values when I call show values. That's explanation what you see here. So you see that the program starts, then we have the variable A being constructed, and then I'm showing the values of that variable. And here the ID is internal sequence counter. So it was the first variable where I called the constructor, was the variable A, and then the value printed. Same for variable B, which was created right after A. So it's the second one being created sequentially. Now we are calling the procedure do something. Inside do something, we create another variable of my record type, which is X. Then the sequential ID is now 3. So this is the third variable being constructed of my record. Now, if you did not notice in this code, I also have a nested code block. This code block is a nested code block. Normally, in the past, this would make no difference in a Delphi application. Nowadays it does, and I will show you why. But with the standard records, you will not see any difference, not now. So that variable inside that code block, the nested code block, we are creating the variable C. The variable C then is being created inside the nested code block here. So it's the fourth, my record variable being created. And then finally, after that nested block, we are creating here the variable D. So nothing special here. This is what you would expect. This is like the way you have always seen your variables and records created in Delphi since forever. So there's no big difference here. Just bear in mind that I'm intentionally putting a header right at the beginning of the program and another one right at the end of the program. So these are our boundaries of the program, or at least the ones we are used to see all the time. But there's additional code being executed before this header is printed in, namely the runtime library startup and anything that the Delphi runtime code needs to do before loading your program, blah, 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 yada, yada. Same thing here. This is the last thing you see from your code, but after that, there's also some cleanup code done by the executable in the runtime library that you don't see that. But this is like the boundaries we are normally used to see. Now, I have another sample program here. Instead of standard records, now I'm defining a custom managed record, which is a big improvement in Delphi since Delphi 10.4. Custom managed records means that now, in addition to creating my convenience constructor and also in creating a convenience method to use my records, just like as if they were classes, the problem with these two is that they were totally manual. They were optional, so not enforced by the compiler. And if they were there, you would use them on your own and at any point in time. So they were not related at all to the actual construction of the record. The record was actually being constructed the moment you are declaring it, you are declaring the variable. In other words, when I declare a variable, like in this code here, that moment that variable is being created immediately because this is a global variable. So it doesn't rely on me to call, unlike classes, objects, which you need to explicitly call the constructor so that the memory gets allocated and you get the pointer and the reference assigned to your variable. Objects, you need to do that before they actually exist. But a standard variable, like in this case, A, can be a global one or can be a local like this inside the function one. The moment they are declared inside the function or globally, that gets instantiated immediately. So what happened with these two traditional constructs is that they were not linked to the actual lifetime of the records. What Delphi did in 10.4 is the custom managed records exposes these three functions, which are handled specially by the compiler. And the neat thing about this is these are truly tied to the real lifetime of the record. So now you have the chance to do something when the record is originally created. So the moment the compiler is creating your instance of a record, you can use this function to intervene and do something customized on that record. So you have a chance, the compiler allows you to do something the moment the compiler is creating your record. And by the same token, you have the chance to do something when the record is just about to be eliminated and then done some finalization. And also gives you the option to do something if you're going to copy your object, your record. If you're going to copy it, then it will call this function that you can redefine. So you can customize how the copy is going to be done. If you don't define any of these three functions, it will do what has been doing since forever. Just treat it as a normal record by value, and then transfer everything that is inside the record as is to the other one. So that behavior is still there. But now you have the chance to alter that behavior by redefining these three functions. So I'm doing that right now here in this sample customized records. So I'm defining them here. Sorry, here. And then also I'm defining some code. So in this area, you can see that hold on one second here. In the creation, where I'm leaving it as is, so the constructor is being called the same way it was in the original code with a standard record. But now I'm catching or redefining the behavior for the initialization. So namely what I'm doing here is this is called right after the compiler created the record, either globally or locally in your function, depending on where you define it. It will call this function, and then you have a chance to actually customize how the record is being initialized. Now I'm doing the same thing as with the constructor. I'm showing on the screen, hey, initialize is being called, and this is the same ID that I've been showing before, so we can see a sequence of what's going on here. Then you get a call here. Right now, I'm all just zeroing them out, which is similar to what the compiler would do. But here, the idea is you could have some dynamically allocated objects or some non-standard stack allocated objects that you can now do here in a record. And this is the novelty. You can create an object here on the heap and assign a reference here. You can do whatever you want because now you control how the record is being initialized. For finalize, I'm just putting on the screen that finalize has been called, and again with the same ID, so we can get an idea of what's going on. And then on assignment, I'm just doing the normal assignment. So I'm not introducing any fancy behavior. I'm only trapping them so you can see when they are being called by the compiler. So let's compile this thing and see what happens now. Another thing is for right now to go simple, I'm commenting out all variables except A. I'm leaving just the variable A. You can see that variable A is a traditional one. Define it at the header, right before your main block, the main program call block. So I will call this header defined variable, which is the traditional way you've been doing it since forever, so that you can see what's the normal behavior with a header defined variables. Then we compile this code. We will go back to, oh no, sorry, I need to switch it here. All right. Compile. Okay, then go back here. Now go to the second screen. CMR2. Okay, now you could see the trapping on this here. The big difference with the previous one is Here, the first activity you could see is when the header of your main code is being written, the title of the program, the header of your main code. And the last thing you can see is exactly the last line that I'm printing out at the end of the program. Now, the difference is before the header of your program is being printed out, you can see that here is the initialization of the variable A. Since variable A is a traditional one, it's a header variable that is being defined at the header of the program, this is the first thing that the compiler is doing, is creating your variable A. And this is happening way before your actual main code starts. That's why you would not see that before, but now you see it because I'm trapping the initialization of variable A. So variable A is being initialized here, and then the main code starts. You can see here the header of your main code. Now I'm calling my custom constructor. This screen proves what I've been telling you, that the constructor is just an easy convenience for you, but the constructor was not really tied to the moment your record is being created. So it's the constructors for records in Delphi is just a convenience, but they are not tied to the real lifetime like they are for objects. In objects, yes, the constructors are the ones actually creating the object. They are truly tied to the lifetime of the objects. But in records, constructors are not. It's just a convenience for you to initialize and assign the internal values. But constructors in records, traditionally in Delphi, they are not tied. But now you are. But you need to trap that new function, initialize. If you trap initialize, you are truly being called the moment the record is being created. Now, you can see that this was the last line of code that we had originally in the previous one. But now this is not the last one. What you have now, instead of this one, the last line is this, when the compiler is finalizing variable A. So you can see that this is what normally happens with traditional header declare variables. Header declare variables are initialized way before your actual main code starts, and they get terminated or finalized after your main code has already ended. That's what you can see here. Is your variable is initialized before your main code starts, and your variable is being finalized after your main code has already ended. So that's intentionally done here so you can see what is the feature, what we are getting now with these new functions of finalize and initialize an assignment. You get the opportunity to be hooking up behavior when your record variables are created and when they are being terminated or destroyed. All right, let's go ahead with a version with all the other variables that you originally had, A, B, C, D, and the X inside the function. So now that you understand what I did and what kind of information you can get with these trappings that I did, let's now run this again on this one with all the variables. So you can see all the possible scenarios. All right, so this is being coded now. I switch to the third screen, and now I call CMR3. So now all you see, all these initializations and finalizations for every single variable that I created in this sample program. Again, the number one being called is variable A, which is a traditional header declare variable. And as we know now, those will be initialized before your main code starts. But the other ones, I'm using the newly introduced inline variable declaration, which is also similar. I think it was 10.4 that introduced this. So inline variables now can be declared the same as C++ style or C style, which means right there at the moment you need them, you can declare that inline. Then they are created at that moment in your code instead of being initialized outside of your code, like the variable A is. All these other ones are being initialized the moment you're declaring them. So this proves that these are truly inline variables. Case given here, you can see that this variable number 2 is actually variable B. Variable B is being created here. So B is an inline variable, unlike A. A was declared outside, it's a traditional header declared variable, but B is totally an inline declared variable. So as you can see, it's only at that moment when it's been declared inline that B is initialized, and then right after being initialized, immediately the constructor is being called. So here they are truly one-to-one, but because of the nature of being declared inline, so I'm calling the constructor at the same time that I'm declaring the variable. So I'm combining the two. This declaration calls initialization, but at the same time, I'm also calling the constructor. So here, in this specific case, we can say that yes, they are linked one-to-one. The initialization and the constructor is when you have inline variables declared like this, then yeah, the lifetime is truly linked between the constructor and the true initialization. Only when you have them declared as inline variables. If you're declaring them the traditional way, header declared variables, they're not. Okay, continuing with this, another thing I want to show you is then we call the do something procedure, and then the internal variable X is being initialized only until you call the procedure. Again, nothing out of this world. This is what you would expect. That was a local variable defined inside the procedure. Then it will be initialized only until you call the procedure. Here, here, when the variable X is being declared. And also because I'm declaring the variable inline. But if the variable was declared the traditional way as local variable here, it would behave the same because it's still a local variable, and it will be only initialized until you call the procedure do something. So following the sequence, you can see that after the procedure returns to the main code, then variable X, which has the ID 3, is finalized because it no longer exists. Its lifetime has been terminated. Here is what you need to keep in mind. This is a perfect example of what C is telling us with the array objects. When you have a variable that is allocated on the stack, just like this variable X, then the lifetime is well defined, is within the scope of that function. That variable will be initialized right when the function is being called, and it will be finalized and terminated right before the function returns. So this is the scope of the lifetime of this variable. And when you define array objects in C++, this is exactly what happens. Those objects are allocated on the stack of your procedure, and then this is the lifetime you're expecting of that object. Then the whole concept of array is tied to the lifetime of stack allocated variables and objects. So just bear this in mind, because even though we know we have this in Delphi, actually it only happens with normal variables like integers or doubles and strings and records, but not with objects. Objects in Delphi will always be allocated on the heap, so they don't follow this rule. Normal Delphi objects. Let's go back to the code, and you can see that here, I did this intentionally again to show you another case of lifetime management that is possible to do only with inline variables. If you have the nested block, this nested block, and I define variable C inside this one, then it will be created right here at this moment, but there's no difference versus B. B was created at the moment I was declaring it. The difference here is that because variable C is defined within this nested code block, then I'm delimiting the scope of the lifetime of variable C. That means that variable C exists only within this code block. So what happens is C will be initialized and used here, but as soon as we reach the end of the block, the lifetime of C will be ended. And you can see that right here. The variable C, which is the ID 4, is behaving like X. Right after being used, it's being terminated. But the other variables, like variable B, variable B is still alive. You don't see any finalization of variable B because it's still valid. V is still within the whole scope. B lives in the outer scope. B will be terminated until we reach the end of the program. But C, if I know what I'm doing, here I'm forcing C to be terminated right here. The lifetime of the variable C is only within this code block. That's what you see here. C is being terminated right here. ID4 finalize. And then last but not least, we have the last variable D that is here. It is declared almost at the end, but still it's in the main scope of the program. So D is being created at the very end, but will stay here until the end of the program. Then we have D being created, is the last ID, initialize 5. And here we're repeating the pattern that we saw in the previous program, the program number 2, is first you see the end of your program. So your main code has been reached here. I'm writing the end of the program. And it's only after your code has been terminated, only after that, that the compiler will then go and terminate all the variables that were declared inside your main code block. So you see by the IDs, you can relate them. So 5 is the D, the last variable that we declare. 2 is B, that was declared way above. And 1 is our variable A, the one that was declared at the header level traditionally. Another thing you can see here is that they are eliminated in reverse order, in FIFO order. So which one, the last one that was created? D, then is the first one to be terminated. Then what's next in order is B, then B is being terminated. And last is variable A, which is the one that is being at the topmost level. So this thing that I shown to you may be a bit boring, sorry about that, but you need to understand what's happening with the lifetime of these variables and records in Delphi, because normally we wouldn't care. But now, because of these new methods that are available to us for custom managed records, we get a visibility on this lifetime of the records. So that's why they call it custom managed records. If you don't use these functions, then your record will behave the same as it has always done. It's the behavior of these initialization, finalization, and assignment is decided by the compiler, and it's always treated by value, copied by value, so no change in the normal behavior. And that's what I showed to you in program number 1. Here I'm just using standard records. I'm not using any of those new features. But this is the catch now. Why would we use, once you have this understanding of the lifetime of the managed record, and that you can do something when the record is being created, and you can do something when the record is being destroyed, here's where the interesting thing comes for us, for the developers. This is what you would do in Delphi to implement ArrayII, but using custom managed records instead of interfaces. Interfaces was your only choice in the past, but now with these changes introduced to custom managed records, now you can do them much easier, much simpler, and cleaner. Now you can do simple ArrayII, very similar to the way you could do it in C++ in Delphi. So what you would normally do in your try finally, now I'm using now Delphi terms instead of C++ terms. This is what you would do. You would have a custom managed record that is bound in lifetime inside a function or a nested code block. So that function or that code block dictates the lifetime of your custom managed record lifetime. And because you can manually dictate that, then you can use ArrayII to have the initialize method of the custom managed record to do something to initialize and acquire some resources, and then leverage the finalize method of your custom managed record to do the cleanup and finalization code. The beauty of this is this custom managed record behavior follows exactly the same way as C++. What I mean to say is the Delphi compiler will make sure that if inside your function, your code raises an exception, the compiler will make sure that this custom managed record gets finalized first. So it follows exactly what you would expect in C++. The destructor, in this case, the finalize method, will always be called even when exceptions are raised. And that's where you are leveraging. Then you can have some cleanup and finalization code inside this finalize method of your custom managed record. Enough of talking. I will give you some real life scenarios and examples so you can see what's happening. Where would you use it? So I'm trying to come up with very simple use cases where this would really benefit for you. Number one, the most important one, I would say, because this is also the same thing, the number one use case in C++, is working with dynamic objects. Objects that are allocated in the heap, which in the case of Delphi is all of them. You have no option. In Delphi, everything, all objects are allocated in the heap always. In C++, it's optional. You can have them on the stack, you can have them globally allocated, or you can have them in the heap. So those that are allocated in the heap, dynamically allocated, this is one of the main uses in C++, how to make sure that the object I'm creating, I'm destroying it properly. In Delphi, we're so used to use the try finally. So in example given, you are creating a string list, then you create a string list, and then you have a finally code block to make sure that you are deallocating and freeing up the string list. So in this case, I'm showing a function called writeText, which creates a file stream. A file stream is an object. It's allocated on the heap. It's allocated to internal inline variable fs file stream. And then I'm passing it to an array II object that I'm calling auto-free object. So I'm passing the reference to that file stream. Then I use the file stream to do some writing. I'm writing here, write text to the file stream and doing some writing. But you can see I'm not calling the free method of the file stream. I don't need to, because I'm leveraging the auto-free object as my array II object. I pass the reference of my file stream to the auto-free object, and then I'm relying on that object. It will free the file stream for me automatically. I don't need to worry. Why? Because I know that this file stream is only used inside the scope of this function, inside of the writeText function. Then this is the perfect case when array II can be used. Then I have created a custom managed record with a specific behavior to handle my object. I call it auto-free object, the custom record. And you can see here, I don't need to remember to free up the object. Also, I don't need to remember to have the try finally clause to free up the object. This is a perfect use case of array II, and this is the most common use case in C++ when you are using objects allocated in the heap. So this is a perfect case where, yes, array II comes handy. Number two case, working with mutexes and locks. So parallel programming, multi-threaded programming is very common to have semaphores or mutexes. In the case of Delphi Parallel, we call them synchro objects. If you're using the standard Delphi library, there are other parallel programming libraries with similar names. But the concept is the same, that a thread needs to have access to a critical part of the code. Like here, we are accessing a queue. This queue is being accessed by multiple threads. Then there's a potential that they are accessing it at the same time, and there's some deadlock or corruption of the queue. So you need a critical access to that one, meaning only one can be adding entries to the queue, only one thread at a time. Here in a standard Delphi code, you have some try finally code to first get the lock on the queue. And once you get the lock, then you add the entry to the queue. And then with try finally, you remember to unlock it. If you don't unlock the queue, it will be in a deadlock forever. So no other thread can use it anymore. Here, following array II, I created an object called, not an object, sorry, it's a custom managed record that I'm calling autolock. And in the initialization and finalization of this custom managed record, it will automatically, when the custom record is being destroyed at the end of this function, the destructor, the finalize method of the record, will unlock this lock. So again, similar to the auto-free custom record that I created in the previous example, this autolock will make sure that it unlocks the synchro object when it reaches the end of the scope of this custom function. And it's done automatically by it. I don't need to add try finalies, and don't need to declare. So you may be taking a glimpse of a snapshot of why this is so popular in C++. You can see that the code looks much cleaner. At first glance, if I didn't explain all this to you, you would say, hey, this is a stupid programmer. He forgot to put try finally. Where is he releasing the lock? Or in the previous example, you would say, hey, where is he freeing up the object? What happened to this guy? Well, if you're using ArrayII correctly, and you are a C++ guy, you will recognize this pattern, this idiom immediately. Oh, he's using ArrayII. And then so simple, you don't need to worry about it. And the code looks much cleaner because you don't have those extra codes just for making sure that you are releasing the resources. So this is exactly one of the key places where, again, ArrayII makes very good use case. But then it's not everything so beautiful with ArrayII. And I'm going to show you one case of why you really didn't need it that much. Sorry about that, this is in C++, but the concept is the same. This is a function that is validating data for a record. So at the end, after the data is being validated, if everything is fine, we post the record to the data table. But here in the validation, this is a very simple example, but you get the concept. When validating, some of the data doesn't meet the constraints that I'm set in my program. My application has this constraint. When I'm calling this function, one of the data fields doesn't meet the constraint that I set for it. I'm raising an exception. And in C++, you call it throw, but in Delphi, you're raising an exception because the validation didn't take place. Some of you might even recall that the dataset objects in Delphi have a specific virtual method called validate for that, an event. There's an event handler for onValidate that does exactly this. And the idea, the documentation prompts you that if for some reason the validation doesn't succeed, raise an exception. That exception will be caught by the dataset object, and then it will release and restates, cancel. If you were editing or doing whatever, it will reset the dataset, and that record gets invalidated. But here, I'm assuming that this is not a specific object. This is just genetic code. The error here is that if the data gets validated correctly, then I will reach line 15 and the data table will be posted perfectly. But if I don't, because the error was raised, the exception was raised here in line 12, then the data table is in unstable state because the exception will be jumping out immediately out of the function. And there is no code. Here, there's no try finally. So here, definitely you see that there is no, the code itself is leaving the data table in an undefined state. But this data table was not acquired here. So here, it would not make sense to have an ArrayII object because I didn't allocate the table just locally inside this function. The data table is an external global object. So here, the concept of allocating and deallocated for doing the cleanup would really not apply. So this is one of the use cases where ArrayII is not your best solution. Here, what you need to do is try finally. Just so simple. You do the try finally. So if the exception is raised, the finally code block will be executed, the cleanup. Make sure that the data table is either canceled or posted or whatever. So just showing you the examples of why try finally is still the best for this, depending on the specific use case. And actually, C++ guys have this problem. When the things cannot be really tied up to the allocation of an object, they need to do all sort of tricks in order to come up with. Actually, in my presentation yesterday, I showed to the C++ guys how they can implement try-finally code blocks in C++ for cases like this when you need one. And then finally, I will give you an example with these real use cases of the object. So I go for my last program here. Here I'm implementing the auto-free object. So you can see it's actually not an object, it's a custom managed record. So this custom managed record, I'm leveraging these functions that we've been talking about. I'm leveraging initialize and finalize. And also I'm intentionally trapping assign because the use case of this auto-free object doesn't make sense with assigning. In other words, this object cannot be copied. I'm using these records to keep track of a pointer to an object that I allocated on the heap. So I don't want this to be copied. It doesn't really make sense. So I'm trapping this one so that you don't accidentally try to copy it. So that's why I need to trap all of them. These two for the actual management of the object that I'm allocated on the heap, and this one just to forbid that you do a copy with it. Then this is the actual implementation. When this is the standard creation of the record, I'm passing over the reference to the object. The normal initialization by the compiler, well, I only need to initialize that reference to nil before I assign it with a constructor. Then finalize. This is the key one here. When finalize gets called by the compiler when the record needs to be destroyed, then I'm simply calling the reference of the object to free itself. And that's how I'm making sure that every time this custom managed record gets destroyed, if it has a good reference to an object, then it will be freed up. Now, what happens if this object reference doesn't have a true valid object here? Well, that's why in the constructor, I'm making sure that you truly pass a valid reference. I'm asserting that the object reference is assigned, that is not nil. Otherwise, it doesn't make sense. Why would you want to keep a reference to a nil object? So that is being enforced when you are constructing the object itself. All right, so here the rest is similar to what I showed in the presentation. This is a program calling a file stream, and the file stream gets passed over to the auto-free custom record. And then I do all my work with the file stream, and I never manually do anything with the file stream. I don't free it up, and I don't have try finally. So let's compile this code, see what happens. So here, compile. I go here, auto-free object. Okay, we creating the file stream object, then it's writing some data, and then the end of the program. I'm gonna type here, this is the data text, the text file that was created by this program. Have a version where I'm exposing intentionally what's happening by defining this. I have a define here. So again, I'm intentionally exposing what's happening on each one of those, so you get a bit more visibility of what these objects are doing. It's the exact same program, only with that define enabled. I get here, I auto free object 2. So here you can see that when I created the file stream object and passed it over to auto free object, then I'm trapping the initialize method. I'm assigning. This one is called by the compiler first. You may recall that I'm assigning, I'm making sure that when it's created, that the reference of the object is nil. And then I'm calling the constructor. The constructor actually allocates and makes sure that the reference to the object is valid, that is not nil. Then they continue to use the file stream as normal. as usual. And after that, the program gets terminated. I did nothing. But then, because the object, the array II object, the custom managed record gets destroyed, then it calls the finalize internal method, and then I get the chance to get rid and free the object of the file stream. So similar to the one I showed to you at the beginning, but now with a real life usable object, the auto-free object, which again is not an object, it's a record, but we're using it like C++ objects allocated on the stack. So this is it. This is an example of how array II can work for you. And you can see, again, once you get used to them, it does make up for cleaner code, because then you don't need to show the finalization part, especially when you need to just free up objects allocated on the heap, and when you need to unlock mutexes. So those very specific use cases that do make sense for array II, the code ends up being much, much cleaner, because those that are familiar with the concept and understand what's going on, they would immediately recognize, this guy is using array II. So that's why no need for any cleanup here. So thank you. This is the end of my presentation. And now willing to get any questions and answers from you.
Okay. Let me just turn this off and do this. Okay, so we should be able to hear you still. Yes. Oh, and we can see you even though your camera freezes.
Yes, it freezes up.
It's fine. It's fine. A couple of people, we had some issues with your screen being a bit blurry in some sections. So people were asking if you're going to make the example projects available for download.
Yeah, sure. It'll be in a repository. I'll be sending that to you, so then you can, with the final posting of the videos of the whole seminar, yeah, they'll be right there along.
Excellent. We'll put the slides up as well. That's true of all the presentations, that we'll put the slides up of those that have had example code in the different sessions. People will get told about them, and we'll email you if we've emailed you already, and if not, check back and we'll probably put it on our blog or something like that. I thought it was very interesting. It's not something I've seen before, I have to say. You showed me some techniques that I'm like, oh, I had never thought of that before. It's interesting, using the managed records like that is a bit of a, I don't know whether it's a bit of a hack, but it's interesting because it does almost do kind of a bit like an interface without all the automatic reference counts in. It's very clever. So as soon as it goes out of scope, then the thing is automatically, cleaned up. And I like that. It's actually very clever.
That's why C++ guys are so used to that. But until now, in Delphi, it was clumsy. Yes, we could use interfaces, but if you just want to do it in those very simple functions or methods, you don't go all through the burden of creating interfaces just for that. I mean, if you already have them there, okay, fine. But just for a quick and dirty function, when you just want array II, now with custom managed records, it makes a lot of sense.
Yeah, cool. Yeah, I mean, it definitely cuts down on the extra code as well. I mean, try finally and try accept is all very well, but as you showed in your examples, it actually makes it a lot cleaner using the methods you've got. It takes a bit getting used to, because we've always used try finally and try accept, but I think the idea of, in some ways, making it a lot safer as well, because if something does go out of scope, then for sure it's freed up, and that's actually very useful for regular records. So Paul McGee said, frantically do my homework, can't wait to watch this on replay later. Paul, you're doing the homework? Really? I didn't think you would still be the kind of, we both know Paul, and I'm surprised he's doing homework. I think he's probably not a student age, but there you go. You never stop learning. Yeah, so I think generally just a few people whinging about the blurring of that. It happens. Look, I prefer pre-recorded presentations because we can control them a little bit, and it streams from either my connection or from the cloud connection. I have a very, very fast internet connection. It's 2.5 gigs, so it is very fast fiber. But sometimes it's not so easy, and it just works out that they're done live. And I get it. Some people like doing them live as well. Adel said it looks like the garbage collector in Java. Is
No
it?
way.
I
No,
don't think
because
so.
no, Java collectors are not deterministic. Array II is very deterministic. And that's why C++ use them so heavily, because the lifetime of JavaScript is well defined by the scope, either the scope of your function or you intentionally creating those nested call blocks like the one I showed. So it's super deterministic. You know when the lifetime of the array object will end. Something that in Java you don't control at all with the garbage collector.
No, and in fact, that's why a lot of C++ and Delphi people don't like Java, because there are similarities in the way that classes work and things like that. But actually, overall, Java is it's not something that most of us actually like. I think so. We've all got a horror story about doing something in Java, I think. Terry said it. I like the fact that his two presentations are related. Here is a way to implement something that C++ lacks, and here is how to do something that Delphi lacks. Something for both groups. Well done. So there you go. You have a fan. Okay, well, we're actually a little bit past that. Oh, and here we go. A couple of other questions. I saw the same auto-free technique in Mormot from Synops. Yes, Mormot does some very interesting object handling and stuff like that. Yeah. And Ali says the presentation idea was excellent and insightful. So you got a few fans there, Miguel.
Oh, good. That I like, because this is new to Delphi developers because we couldn't do it. I mean, I don't have anything against the way we create objects in Delphi. I think because, as I explained, those seasoned programmers like you and me will recall Turbo Pascal did have stack allocated objects. But I think the decision to eliminate them when they jumped up to Delphi was clever. Why? Because they didn't want Delphi developers go with the through nightmare that C++ developers need to do, which is remember, where did you allocate the object? In the stack, global memory, or the heap? And you need to keep track of these three separate cases individually. And
yeah.
Now, this is the power of C++, but Delphi tries to make things simpler. Then they said just one memory model. Everything is dynamic on the heap. So that's why now everybody's used to say, I must call my constructor so it gets allocated on the heap, blah, blah, blah. And we all know this rule of thumb. There's only one rule of thumb in Delphi. But the problem is then array II relies on stack allocated objects, which again, now we have custom managed records. I think that's what was behind Marco's team when they introduced it. They knew this would be a way to simulate a little, not fully, but a little stack allocated objects in C++. Now in Delphi.
Yeah, because as you said, it only came in 10.4 where this would be possible. It's one of those incidences where people say, well, why can't I have this in an earlier version? Well, because the capabilities to have managed records like that didn't exist before 10.4.
Right.
So
right.
And
exactly.
Patrick's impressed at your abuse of records to manage classes. I think that's funny. Yeah, he says, oh, it's a very strange world.
But that's what I had to go through the burden of explain. I did spend a lot of time on explaining the lifetime because that's what's new to us Delphi developers. Again, that's like a normal life for C++ developers, but not to Delphi developers. We are not used to be so aware of the lifetime of the objects you create in memory. Because again, the normal objects will always be in the heap. But what about your variables, whether they are global or on the stack? Records behave similar as variables because they are allocated directly. They are not on the heap, they are directly. Then by doing this, you need to understand the lifetime of the actual record. So then understand why, now that they added finalize and initialize, now you can simulate what you would do in C++ with array II.
Yeah, and your code was good as well because it showed off so many new features like inline variables and stuff like that as well. So If you could have just took multi-line comments and a few other things, we would have got everything into one demo of many of the new features. Okay, well, it's brilliant. We're coming up to 2:17 my time, so I think we're going to call it a day. Very popular. We'll make sure that Miguel's example code is available. And I think this is your last session, isn't it? You're done now, aren't you? I think for this time round. Yes, I think that's it. Yeah. Well, you know, Miguel, I always admire what you do. You are a very smart developer. You come up with some subjects that are absolutely fascinating to me. I'm pretty tired at the moment, and I'm like, oh, you know, it's been a long couple of weeks, but that was a very interesting session, and the way you explained it as well was actually very clear, because it's not something that's sort of faint-hearted. It's actually relatively technical, and yet you made it approachable. So well done on that. And your session yesterday was good as well. So I think you pleased C++ and Delphi people. So that's pretty good.
That was a good fit. But yeah, when I had the idea, I noticed that I actually wanted to do the C++1 of Try Finally, because I had a real use case in one program that I'm running for a project. And as I show in the examples, there's some code that cries for Try Finally. But the C++ way is no, go the array. But there was this code that I don't need to allocate anything. I just want some cleanup code to be run at the end every time that the program exits, the function exits. But in C++, you had no option. That was the reason that got me to go the Try Finally for C++. But then I said, oh, but also Delphi guys would like to see what's array.
Yeah, well, two great sessions and very good. Well done. All right, well, thanks a lot. I'm going to say goodbye to you, and I'll see you around. We always bump into each other at various events and things like that. But thanks a lot, Miguel.
Sure. Thanks to everybody.
Bye-bye. Okay, so Mitch has managed to catch a thumbs up from his camera just at the very last second. There you go. But I'll just turn it back on again, just so you can say, see, he just did a thumbs up just as his camera was working like every 5 seconds or something. So it's good. Excellent. Okay. Well, that does actually conclude our sessions for today. Let me just check that before I say that, because our sessions have been a little bit up and down. Yeah, no, that's it. That is indeed it for today. We've got more tomorrow. We've got a fairly packed day tomorrow. 1, 2, 3, 5 sessions at least, and probably a live one from me at some point, because we've got some sessions moving around. And tomorrow we've got HTMX, dynamic web applications with Antonio Zapata, a smart backpack. Whoa, controlled by a mobile app, and that from Yaroslav. Yellowfin have got not 1 but 2 sessions, and if you don't know what Yellowfin is, you've got to watch, because it's pretty interesting stuff. And then Ali is doing a session, on easy DB migrator, and then finally at the end of the day, the final Yellowfin session, who are one of our sponsors for this event, maximizing customer value with embedded analytics in Yellowfin. You've got to come tomorrow, start from the start if you can. If not, catch us on the replay. If you're watching us on YouTube, click on the like button for this stream, and then click on the subscribe and the little bell to say all alerts. If our emails don't reach you, at least you'll get a notification from YouTube. It's the same time every day. I try and make sure that we start at the same time every day, which today was 4 hours ago. So, roughly about this time every single day. But thank you to all of you that come along. Some of you are regulars, and I appreciate you joining me. And because today's a slightly happier day, I'm going to play us out with our very, what's the word I'm looking for? It's not quite our theme tune, but we all love it so much, so we're going to do it. So this is a video by Jim McKeith and Code Monkey. I'll see you tomorrow.
A program where the code was the codified lyrics to a song, and then the output was the actual lyrics to the song. So much like Walt Disney created Fantasia based on classical music, I've created a special musical number based on the music of Jonathan Coulton.
Code Monkey, get up, get coffee. Code Monkey, go to job. Code Monkey, have boring meeting with boring manager Rob. Rob say Code Monkey very diligent, but his output stink. His code not functional or elegant. What do Code Monkey think? Code Monkey think maybe manager wanna write login page himself. Code Monkey not say it out loud. Code Monkey not crazy, just proud. Code Monkey like Fritos. Code Monkey like Tab and Mountain Dew. Code Monkey very simple man with big warm fuzzy secret heart. Code Monkey like you. Code Monkey like you. Code Monkey hang around at front desk till your sweater look nice. Code Monkey offer buy you soda, bring you cup, bring you ice. You say no thank you for the soda, cause soda make you fat. Anyway, you busy with the telephone, no time for chat. Code Monkey have long walk back to cubicle. He sit down, pretend to work. Code Monkey not thinking so straight. Code Monkey not feeling so great. Code Monkey like Fritos. Code Monkey like Tab and Mountain Dew. Code Monkey very simple man, big warm fuzzy secret heart. Code Monkey like you. Code Monkey like you. A lot. Code Monkey have every reason to get out this place. Code Monkey just keep on working, see your soft pretty face. Much rather wake up, eat a coffee cake, take bath, take nap. This job fulfilling in creative way, such a load of crap. Code Monkey thinks someday he have everything, even pretty girl like you. Code Monkey just waiting for now. Code Monkey says someday, somehow. Code Monkey like Fritos. Code Monkey like Tab and Mountain Dew. Code Monkey very simple man, big warm fuzzy secret heart. Code Monkey like you. Code Monkey like you. Code Monkey get up, get coffee.
This is actual Object Pascal code and was recorded in real time. You can compile it with Delphi or App Method and run it on Windows, OS X, Android, and iOS. The output is the original lyrics to the song. The code will actually work as a console application as well, and so in theory could work on other platforms like Linux, etc. Just in order to make it shared code, I made it a GUI application. I hope you've enjoyed this special musical number, and my thanks to Jonathan Coulton for making and sharing this great song. You can download all my source code for this song on my website at delphi.org/codemonkey. From there you'll find links to download Jonathan Coulton's song as well.
Thanks a lot, everybody. See you tomorrow at the same time. Like and subscribe, and you won't miss anything. Bye. Oh, and by the way, in answer to the questions, of course I was singing along to the tune in the background. That's why we play.